concern related to multiple data sources. There is no single reliable source of the data for the farmer, so there is a lot of confusion when you go to the different kind of sources. And then coherence is a problem among the government organization, and everybody knows that public-private partnership is little weak in the country, and data consistency and redundancy is also a problem. So there's a lot of requirement from the ICT point of view, and there is a need for agriculture intelligence system countrywide, covering different areas from planning, production, and post-production, all these sectors covering the whole agriculture production system and value chain. And of course, we need to have some ICT platform where we are working from the council side. So when you look back to the digital infrastructure, so there is a huge growth, tremendous growth in India, and you know that all of you must be knowing that the world second largest mobile phone market is India. So we have 25 million mobile subscribers now. Penetration rate of mobile phones are 86% overall. And smartphone especially, you will be surprised to know that 54% penetration is there. When you come to the internet penetration in the country, it is reaching around 50%, and especially cities, it is more than 70%, and rural areas 40%. But number of Digital India schemes are going on now by the government side, and maybe in the next 2 years, it will cross about 60%. Lot of systems we are going to develop in ICT sector for the developing a common platform, and India-Stack is one area where government is focusing, and based on this similar architecture of the ICT, where we need to have a common digital platform for the communication with the farmers and all stakeholders, and linkage between the structure for communication across different stakeholders. So when you talk about the ICT technologies, so these technologies are called disruptive technologies. You know what are the disruptive technology means? The technology which can change the human behavior and way of thinking and human thinking all of a sudden. They disrupt the normal thinking process of the human being. So machine learning, deep learning, AML, IoTs, blockchain, VR, robotics, all are disruptive technologies. Disruptive technology, best example is that WhatsApp, you know. After WhatsApp, you know, the telecommunication system, or thinking about the telecommunication, is everything is changed across the world, and communication development, and there are a number of systems which are moving on the cloud, and security also. Cloud is a very secured environment, so cloud computing is also one of the coming up ICT technologies. Edge computing means computing, instant computing basically, on-site computing, so you don't need to go to the cloud for computing and communicating from the servers to this. So now, especially when you talk about the drone, or especially when you talk about the IoTs, so edge computing is one of the requirements where people are working now, because you know, when you from the field to the server and server to the field, by the time there's a lot of time lapse. So edge computing is one area which is coming up very fast. Now I'm coming to the activities of ICR, where ICR is taking a lead in the different areas of the ICT based technologies. So basically Phenomics is one of the area where ICR is already leading in many ways, and this is one center, that is Nanaji Deshmukh Plant Phenomics Center, which is in IRI, and which has been inaugurated by Honorable PM. So this is one of the image of the center. So you know, this is a very advanced center where a lot of IT and ICT based technologies is being implemented for the phenomics of the plant phenomics basically. And you know that this is the whole system of the plant phenomics, There's a solar radiations, plant absorbs these radiation, and then something is reflected and something is transmitted. So whatever is transmitted and reflected, that is being captured under the plant phenomics, and from there we try to derive the different attributes. And this data is being captured by different sensors. And same thing, whatever experiment is being conducted under this plant phenomics center, and if you find time and whenever you are visiting, you must visit this. It's a very advanced ecological center. So, plant data captured by cameras with the different sensors. So, same experiment has been laid out in field conditions also, because there's a phenotype, genotype environment interactions are there. So, mobile platform is also there, and then drone also we capture the same image. So, then we try to compare how this under a controlled environment, what is the status of the plant under the different phenotypic characters. Same characters are captured in the field environment conditions through mobile platform and then through drone also. And then we try to integrate with the genomics. So altogether, you are able to draw the conclusions. So these are the facilities in the phenomic centers of IRI. And a lot of cameras are there, thermal camera is there, chlorophyll fluorescence cameras are there, NIR bands are there, visual bands are there, then hyperspectral imaging is also done. So the same plant is being captured, image of the same plant is being captured, and a lot of phenotypic characters and plant physiological characters has been derived based on this image and computer vision. So this is one of the centers where a lot of experiment is being now conducted, and their ICR is ready, and this is being replicated to the different ICR institutes also now. So here, the image is acquired and then it is pre-processed, then segmentation, feature extraction, then machine learning and deep learning algorithms has been applied, and then the phenotypic characters have been derived from the plant, from this analysis, and a lot of IT and ICT based disruptive technologies is being used for this, and then as I told, a lot of plant physiological and plant phenotypic characters has been derived automatically. That is, non-invasive techniques are being used here. And I was associated with this number of experiments when I was in ISRI, and I tried to extract the information, and we developed a complete software basically. A lot of algorithm has been developed by my team using this huge data capture. Images, millions of images are being captured for the same plant over a period of time. After every 4 days, the image is being captured from each of the plant, and then it has been analyzed. So a lot of data mining and data analytical techniques are being applied in this, and this is the whole process we used to follow in this analysis. So this is one area where ICR is in very advanced stage of research, basically, and this is the first center, I think. Now Icftca has also is developing now. So this is one of the centers where a lot of ICT tools and IT tools are being used. Then bioinformatics and computational biology, I understand there are some talk in this particular international conference related to this. This is started in 2001, and a lot of work has been done in this area, especially in the area of livestock and fisheries. This is being extensively applied in Europe and US, and genetic gain in this by application of this genomic selection is up to 30 to 60% in the animal science. Animal means cattle. And basically, here what we do is there's a population we have to have, and there's a breeding population, there's training population, and you get the data on the training population for phenotypic and genotypic, and whole genome has been taken into consideration instead of the part of the genome which is being done in the molecular assisted breeding. So it is just advanced version of the molecular assisted breeding, where the whole genome of a individual is being taken into consideration for the selection, for the breeding. And a lot of AI and ML techniques have been used for the modeling. And when I was heading a center of bioinformatics, Center of Agriculture Bioinformatics in ISRI. So we have developed a lot of algorithm into this area using this AI and ML techniques, and there is a multivariate mixed models are there, and there are Bayesian approaches are there, parametric approaches are there, single trait selection models and algorithms are being developed. So I'll show you some examples where we have written. So as I told you that we have done a lot of work in the genomic selection, but unfortunately it's not being adopted till now in many of the areas in India. And for developing these models and for customizing this models are already there, and we have algorithms also with us in ICAR. But for customizing these models to our environmental conditions, you need to have at least 5 to 10 years data, phenotypic data and genomic data of the individuals, and then you can train your model. And presently in our cattle, our genetic gain is around less than 1%. And while applying this same techniques and genomic selection tools, in Europe it is around 30% genetic gain. So you could, if you apply these tools and techniques and algorithms, so your genetic gain is likely to improve drastically in the country, and now government is already taking a step into this area. And then now I hope in next 5 years we'll have a lot of impact of this particular genomic selection process. So we have done a lot of work into this area, and we have done a lot of work in statistical and data mining techniques also, either for selection of the important genes, trait-specific genes from the data set, or polymorphism, identification of polymorphism, or QTL analysis. You talk about single cell RNA seq data, which is the latest area of genomics now. Huge data is being generated, and a lot of techniques has to be used in this area. Or when you talk about the metagenomics, this is this paper related to metagenomics algorithms. So metagenomics also, huge data is being generated, and how to manage and analyze the data, and how to extract the knowledge from the data, that is very important. So a lot of work has been done, and a lot of IT tools and disruptive models has been used into this area. So this is one area which I would like to touch in this talk. Then also by applying these tools and these techniques, we have generated a lot of web resources, and they are already available on the site, which is called the National Biocomputing Portal, which is hosted on our supercomputing system, which is called ASOCA. Full form is Advanced Supercomputing Hub for Omics Knowledge in Agriculture. So all these web resources and tools are available, and they are accessible free of cost to the whole world, basically. So a lot of these are some of the examples I am showing, but a lot of work has been done in this area in last 10 years. This is a progress of last 10 years in ICR, and a number of papers have been published in this area. So you can see, either you talk about the onion, or you talk about this mango, or you talk about this bioenergy or banana. So almost all important crops of the country has been touched uh, by ICR. Different institutes are associated in this work basically, and a lot of pipelines are also being developed for extraction of this whole information from the big genomic resources, which are either freely available or which are being generated by different labs of the ICR. So similar thing has been happened. A lot of paper and publication has come up last 10 years, especially in transcriptomics and proteomic analysis. So these are some of the examples which I am showing, and where my team and myself was associated with these publications. So that is related to the biotic stress, abiotic stress, or metabolomics. You can see this paper is related to the metabolomics, and then in different crops basically. We worked into different crops in ICR. Okay, this is one slide which I would like to especially mention, and basically we have taken the DDNAT sequences, and we and generated around 1.67 million high quality SNPs, and then we try to classify all our mango varieties, taking samples from different regions, and 84 mango varieties from different regions has been taken into this. And you know, you'll be very surprised. You can see this diagram. There are only two subpopulation groups are there in the Indian mangoes varieties. You can see this phylogenetic tree where broad categories are 7 broad categories. You can classify all the characters of the mango based on their SNPs. But broadly, there are two subpopulations are only there. One is red color population you can see, and how this is green color populations are there, and then a lot of work has been done in this area. And basically, we have also did the whole genome sequencing of Amrapali variety, and that is under publication. So that is going to be published very soon. And Dr. N.K. Singh and his group basically did a lot of work in this area, and we were also associated with this. Now coming to the computer vision, which is one of the area of ICT, and where a lot of R&D is going on basically. It's still it has to be matured. So this is being used for the detection of diseases, estimation of yields of the fruit crop basically, fruit crop, and non-invasive evaluation of attributes like quality, appearance, volumes, and robotic systems. And our number of ICR institutes are working in this area. And this image basically you can see where the fruits are being identified on the tree. And I will give the next slide. I think it is visible. So, you know, when you talk about the estimation of yield or the detection of any disease, and this is a drone image basically. So drone is moving around. It's moving around in the orchard and around the tree, and basically it is counting. This is an orange tree basically, and it is detecting this fruits, and then identifying mature fruits and the fruits which are means not eatable basically. And there we have used the CNN network. And basically this is used for the estimation of production or logistic planning, precision agriculture, as I told you, monitoring of diseases, and or identification of nutritional deficiencies, especially the nitrogen and water stress. So when you talk about this, so you need to have a lot of analysis of this whole video. This is video analysis basically, where you have to see that the one fruit is not counted 2 times. You know, when you take an image around the clock and some of the fruits are hidden, there's a issue of the shape, compactness, orientation, lighting issues when you take the videos. So this is one algorithm which is very popular, structure from motion, and where we try to remove all these anomalies. Still some errors are there, but it's a very accurate system now we have developed. And few of our institutes are also working in this area, and we are promoting this. And this is other example. This is from the CFET Ludhiana work, where basically this work is under a network project on precision agriculture, which I am coordinating the whole program from the ICR side, where this is a grading system basically. This is for mango they have developed, and grading based on their shape, structure, as well as the quality of the mango basically. You can see this, if there is a malformation on the mango, it will automatically reject. And this is a whole machine vision and sensor based grading system they have developed, and the accuracy is quite okay. 97% accuracy they are getting. So this is a grading system, and we are trying to make it commercial very soon. Now coming to the precision agriculture area, I think I have few more minutes. I'll just go fast. So as I told you, in ICR we are having a network program on precision agriculture. Where are 16 ICR institutes are working in different areas, covering the whole gamut of the agriculture basically, where they are talking about the soil health and crop health, precision management, VRTs, robotics, post-harvest quality technologies, precision dairy, precision fisheries, and scaling up to the field level. Some of the technologies we are also going up to the field level. So these are different platforms which we are using. And our scale of research is from the control lab conditions, from the phenomic centers to the experimental field and the farmers field. We have taken some major crops, this is listed here, like rice, wheat, cotton, banana. From each category, one or two crops we have taken, and we are focusing on this area. And cattle and buffalo and major crops, post-harvest and agri-produce, soil, weather, sensor and agri-machineries. These are some of the outcome which has come in last 2 years, because since last 2 years this program is active. Sensor-based rapid fertility assessment and mapping. This has been almost finalized, and you can see this diagram. Basically, this work has been done by Indian Institute of Soil Science and NBSS LUP, Nagpur. And you know that we have almost finalized the whole SOP, and in 6 districts of Odisha we have developed this digital soil map, and where we are now testing through the field, and the mobile app is also developed. And when you go take a mobile app to some location, coordinate it will pick up, and it will tell you the estimated soil status of the particular location at the farmer's field. So this is one work which is going to be very useful for the country. And then drone-based crop nutrient monitoring and management, large number of work, large of experiments has been conducted in this area. And near real-time satellite-based and crop condition monitoring, especially for the nitrogen deficiency and water deficiency. These two parameters we have standardized, and now we are trying to validate our results to the farmers field level. So this is this kind of experiment we have conducted in last 3 years with different levels of nitrogen, and then we have captured the images, and we try to analyze the this SOP for this. Then in cotton we have worked on these 3 diseases, and based on the image based algorithm, image based algorithm we have developed for identification of these diseases. And but still work is going on. It's not final stage. It is almost final, but not very. So, and similarly for the nutrient also, and you know, this work is being done by our Cotton Research Institute, and pheromone based this uh, uh, this is pheromone based monitoring we are doing for the insect and pest, and for the cotton insect and pest. And now we are trying to test this basically in the farmers field level also. So lot of good results has been there. I will not go into the details of this. And similarly for the BPH for the rice and rice and wheat aphid, rice blast. So these are some of the experiments which is done, and some of the things are going to the farmers field level. And also MGMG villages also we are trying to validate these results. Once these validation results comes out, then we are going to upscale up to the country level. IoT based irrigation systems in all of our president ICAR institutes and are very intensive. And this system, this particular IoT based system has been developed by our Institute of Water Resources, Indian Institute of Water Management. And now we are testing at a different ICAR institutes like IIVR, Varanasi, NRC, Banana, same test system. And if it is now under validation at the farmers field level also. So this is for the paddy sensor based for the paddy fields, and it is controlled by the mobile. And this is for the maize crop. Experiments are going on. Similarly, for the fertilizer recommendations, our fertilizer recommendation system has been developed, and especially NRI Cuttack and IIWBR Wheat Research Institute of ICR, they have developed it. And now, based on this digital soil mapping and this particular systems, we are trying to validate this on the field based on our mobile app. Some of the districts we are trying to test. Coming to the smart urban agriculture, in IRI and IIBR basically, and IHR also, some work has been done, and there's a lot of saving on this hydroponic farming systems. This we call is a smart urban agriculture or vertical farming also. So this is smart production system for protected cultivations. These are images from the IRI Pusa, and precise fertigation and watering system has been implemented in this area. And around 66, more than 66% water saving is there, and around 25% higher yield you get just by implementation of the sensor. Just by implementation of the sensor into protected cultivations. And similarly, it is done for the capsicum also. These experiments are conducted in IIVR Varanasi, and this is the second year now we are doing it. Hydroponic models are being developed. These images are from the IRI Pusa, from PAL and IRI. So this is one example of variable rate fertilizer applicators. It is there already. Then robotic apple picker. You can see this. These robotic arms which identify the mature apples and pick it up. Robotic weeders are there. And then mango grading system we have already discussed. This is a work from the CFET Ludhiana, sensor-based multi-pass cleaner for the pulses, major pulses. They clean it, and even they identify the broken grains. That is a machine vision-based broken grains, infected grains, and all our grains they identify and they segregate. Then blockchain technology we are implementing on the banana crop. And we are trying to have a traceability system for the banana. We are experimenting it. This is the second year of experiment. And this is again developed by the CPET Ludhiana, and NRC Banana and CPET Ludhiana are working together. This is a sensor which monitors while banana is being carried on the different transportation system. It monitors temperature, relative humidity, ripening, ethylene based system is there. Time and location also it gives you, and it tracks the whole supply chain. So this is blockchain based system we implemented. Precision aquaculture, our three institutes are working together. One is a CIFRI, then CIFE in Mumbai, and then Bhubaneswar CIFA. So this particular system this is a sampler, water sampler, which has been developed by CIFRI, and it can go to any location. This is an example of Ganga River. Similarly, automatic tracking system and counting system is developed by the CFA. This is the tanks hatchery system, which is sensor based. It has been developed by CIFA. So a lot of work has been done into this, and this is geospatial decision support system using the Google Earth engine, and this is for the this is developed by the CIFRI, Calcutta. So this is detail of it, this work has been done, and this system also have a sensor which can identify the water quality as well as the aquatic environment also. So this is a robot which is for the fish monitoring, underwater robotic systems. This is a pond. This is a pond where quality monitoring, especially the dissolved oxygen and ammonia, is being monitored. And this is automatic tracking and counting system. You can see the fishes. The sensors are identifying their health as well as the size of the fishes underwater. Precision livestock also, a lot of work has been done, especially in mastitis detection as well as the pasteurization time of the animals. This is a video-based whole analysis is being done, and this is a sensor-based detection of mastitis disease, and heat detection also based on the pedometers on the animal's leg. So early identification of the clinical and subclinical mastitis. This lot of work has been done in this by NDRI Karnal. And this is whole images and whole system of automation, smart hatchery, and fish feeding system by CIFA. So now I'll conclude basically. These all experiments are going on, and we have a lot of SOPs. But still the cost of the technology is more, and it may not be affordable to the farmers when you roll it out. So the key to the success of these whole R&D outcomes are we need to minimize the cost of the technology. Basically, sensor costs are very high, so we need to develop indigenous sensors because most of the sensors are imported now, and easily portable hardware should be there. A farmer cannot afford to put their hardware system at the field conditions, in India. Renting and sharing platform for agriculture equipments and machinery. So this has to be some policy issues are there into this, and this has to be promoted by the government. Policy orientation toward facilitation of digital agriculture, extension services and agriculture related academic institutions, ease of access and operation, giving training to the farmers level training programs, and this high-end technologies is very difficult. So our technology should be easily accessible and easily operable. Easy maintenance of the system. Maintenance is one of the issue may come into the farmers field level. So now some of the platforms which are for dissemination of the technologies, this is one platform of technology repository. Then this is one program, Kisan Sarathi, which has been launched by Indian Council of Agriculture Research in 2001. And this is a digital platform. I'll be happy to share you that now we have 1.65 crores farmers linked to this platform, where the multilingual multimedia advisories are being sent by our Krishi Vigyan Kendras. All 731 Krishi Vigyan Kendras are attached with this. All farmers, 1.65 crores farmers are there, and this mobile app is also there. Social media platform also we are using. And these are toll-free number where farmers can call on this toll-free number and they get the advisory by our Krishi Vigyan Kendra experts online. And a lot of features are there. I have no time to explain it. So a lot of features are there into this there, and we are extending this program to the. We have extended this program basically in 13 languages and the whole country. This has been rolled out. These are some of the mobile apps. There are more than 300 mobile app has been developed, and we have integrated all the mobile app of ICAR into this single mobile app basically. Kisan, which is called Kisan 2.0. So all mobile apps are integrated into this in different languages. We have a KVK portal for dissemination. And I am happy to share that Niti Aayog is monitoring all digital activities of all departments. And we are one of the topmost department which has been rated by the Niti Aayog, And we are in the green zone basically. And ICR is very much appreciated for their digital initiative. And these are different e-governance platform. I'm not going to talk about it. Number of e-governance platform has been implemented. And digital governance quality index for ICR is 4.43 out of 5. So we are one of the topmost departments among the 10 departments we are rated. So with this, I thank you very much, and sorry for not joining again on the site. And I'm again thank you to the organizer for giving me this opportunity to talk to you. Thank you very much. I'll unshare it.
Yeah,
okay, it is unshared.
Dr. Anil Rai.
If there are any queries, I'll be happy to answer.
Sir, are you able to hear, sir? Dr. Anil Rai, are you able to hear? भैया यहाँ देना है ना, तब से बोल रहा मैं. हेलो हेलो
Sir, am I audible, sir? Sir? Anil,
yes,
sir,
yes.
am I audible, sir?
Sir, are you? We are audible to you, Anil Rai, sir?
Yeah, now it is clear.
Yeah, sir. Thank you very much for your extensive talk on ICTs in agriculture. You covered almost all the things. That's what I say, that if you could have come, it could have been much better. I know the difficulty, Parliament session is going on, but it is really excellent talk. Our student delegates, I think, agree with me that he has shown all the, from the data generation to the data processing and image processing, and I think I've written 4 pages on this. I don't want to repeat, but personally I got so much knowledge from your talk, and some of the things we are only doing few of the things what you said, like software development and mobile apps and some of the digital tools we are using, but yet we have to do much more. I think we will be interacting with you more. I think this is one of the wonderful talks, and you all join with me in clapping to the Dr. Anil Rai for the excellent talk.
Thank you very much, and again sorry for not coming there.
Yeah, we will call you some other time, some other platform. We will definitely call and we'll have interaction more. Before that, before I call to the next speaker, if any pertinent questions or any clarifications, one or two. Sir, will you spare for another 5-6 minutes?
Yeah, please, please.
Yeah, and then I will take a few questions, any pertinent questions you have. Please raise their hands and our people will give the mics. Anyone? I think all are very clear. I mean, yeah, please. वहाँ दे दो. Somebody is asking, sir, please wait. वहाँ दे दो.
Sir, is it audible?
You take this, otherwise. You can come here also. I mean,
Sir, is it audible to you, sir?
Yeah, it is. It is.
Sir, the Central Tobacco Research Institute, now it is going to transform to NIRCA, and where our the other crops will be, in addition to the tobacco, we are having the chilies, turmeric, ashwagandha, and castor. In chilies marketing system, and we have the special problem, while grading, there is anthracnose, one disease, what is called the fruit rot. This particular, presence of this anthracnose while marketing, if at all some fruits are there with that infected fruits, the farmer is going to get the very less price. Is it possible for us, while it is going on the chain, that is on the, what is that called, on a track, is it possible by using any sensors, by using the digital technologies, is it possible for us to pick it up and then select it and pick it up, and so that we can have, the farmer will have the better price for that?
Yeah, you need to develop a sensor-based grading system for the chilies.
Yes, sir. Broadly, it is.
So that is possible because it is done for pulses. So chilies are much bigger than the pulses. Pulses grain-wise, it is grading. So accordingly, you need to develop this sensor-based grading system for the chilies. It is possible. It is possible and very much possible.
Okay, sir. Thank you.
Okay.
Dr. Rai garu, you are very much
Yeah.
by your talk, sir. I'm very happy.
Yeah.
I'm Dr. Padma Sri from University of Hyderabad. I might have missed, but kindly let us know. I was very much impressed when you said fruit quality, ripening stage, all those will be also identified. Am I right?
Yes. Yeah, it is.
Sir, have you,
Please.
yeah. Have you correlated with the wet lab experiment, sir?
Yeah, it is. Otherwise, it is not possible. No. First, we have to correlate with the wet lab experiment.
Okay.
And we have to take the image, and we have to see, and then we build a model.
Okay.
And accordingly, it has to work.
Okay.
Otherwise, it cannot be done.
Yeah.
Okay.
Okay, sir. Thank you very much.
Okay. Thank you.
Yeah.
Any question?
Yeah, Dr. Mani, you have to come here. Yeah, one more question, sir.
Sir, good morning, sir. Myself, Dr. Manivel, Principal Scientist working here, sir. Sir, whatever the sensors, whatever you are mentioning is about the primary metabolites or primary nutrients and all. So is there any possibility of estimating secondary metabolites with the sensors and other things? Because that is essentially needed for when we go for quality aspect of not only medicinal plants, turmeric, chili, everything, sir.
Sir, are you got his point?
the secondary metabolites, no, he is saying.
Yeah.
Hello?
Yes, sir.
Talking about secondary metabolites.
Yeah, he's talking about secondary metabolites.
Uh,
Yeah.
so till now I have not come across any development in this area. So till now I don't think it is possible, or it may be possible, but nobody might have attempted it.
Yeah. Okay, sir.
Okay.
Yeah.
Okay.
Once again, I extend my uh, uh, for your sparing your time here, and I extend my gratefulness to you for sparing and telling a very great topic on ICTs here. We have a lot of application, as my colleague said, that we are moving one crop to another. 4 crops are added in NIRCA, like chili, turmeric, ashwagandha, and castor, where a lot of work is there, which I was telling you when I was with you in 7 days in Hyderabad. We want to use a sensor for quality determination, sensor for moisture, IoTs in irrigation, and some of the grading things in tobacco and chili. And of course, we have a drones, but we still not taking a data and want to use. And we also have a 2 kV case with me, where we can use your integration tools like we are using now, Kisan Sarathi and all. So a lot of things are there. I mean, personally, I can discuss with you, and then I can make you. Thank you very much for sparing your time, and definitely it is a wonderful talk in this international conference. Thank you, Lord, sir.
Thank you. Thank you very much.
Thank you.
Thank
Sir.
you. Thank you.
Yeah, now we have a second talk from Dr. Neeraja Prabhakar, Vice Chancellor, Sri Konda Lakshmaya, Telangana State Horticulture University. Madam is going to talk on new perspectives in chili and turmeric cultivation for sustainable farming.
Can I have my the laptop is there?
Yeah, laptop.
Here. And you can అక్కడ ఉంది laptop. Just I'll
Hema,
use this one.
where are you? Are you?
Once again, warm welcome, madam, to the international conference. Thank you for coming. Madam has been the.
Just I want to tell about what is the horticulture sector position in Indian agriculture. It is contributing about 30% of the agricultural GDP just from 14% area. That means we are getting more productivity per unit area when compared to the other agricultural crops. If you see that there is since from the independence from 1950-51, there is a tremendous increase in the production of horticulture by 342 million metric tons by the year 2021-22. That shows the 13-fold increase. So where we can exploit these horticulture crops to improve the national economy as well as economic level of the farmers. If we'll compare with the agriculture crops, only the 6-fold increase. If we'll compare with the so other things are much more better than the horticulture is like fisheries, that is 18 times more, and of course eggs by 53 times, so like that. And if we'll see the productivity, as I said before, compared to the agricultural crops, these horticulture crops, we can get 12.5 tons per hectare when compared to the agriculture crops only, that is the 2.23. There is a much more scope if you will convert as a part of the crop diversification from the regular field crops to the horticulture crops. So we are first, in the production of banana, mango, guava and papaya. In case of the vegetables, first in okra, onion, and chilies and beans. Of course, shallots also comes under onion family only. Then second in the potato, tomato, cauliflower, broccoli, brinjal, cabbage, green peas. But in spite of the first, we are producing much more like a chili, but still there is a much more requirement of the conversion our area into the, bringing into the non-traditional areas under the turmeric, chili and other medicinal herbal plants. So being commercial, high value commercial crops, so which will give high returns and that requires that post-harvest processing, value addition, and they have tremendous export potential. So in this one, I am going to deal with the main two crops, that is the chili and turmeric. If you'll see the status of cultivation of this turmeric, so here India accounts about 85% of the world production, followed by China only 8%, that is in Myanmar. And the average productivity is highest from India only in turmeric, that is 3,980 kg per hectare, then followed by China. So we are talking about always China is first and with high productivity this one, but here we are happy that we are leading in this turmeric. And if we'll see last year, so in the present year it is about 3.24 lakh hectares with the production of 11.61 lakh tons. And in India, Telangana stood first, then followed by Maharashtra. So Telangana with 28.09% and Maharashtra 22%, then followed by Karnataka, Tamil Nadu, Andhra Pradesh, Madhya Pradesh and West Bengal. If we'll see the productivity, but Karnataka recorded the highest productivity with 6,100 kg per hectare, followed by Telangana with 5,576 kg per hectare. Here, our technology plays vital role how we can increase the production with quality turmeric. So quality means we'll talk in the point of view like curcumin content and oleoresin content. So if we'll see the export of the turmeric, so during 2022-23, 1.534 lakh tons of turmeric and turmeric-based, value-based products, so worth of like $207.45 million exported by more than 380 exporters. So India exports about 10% of the total turmeric produced. That contributes to 60% of the world export solely from India only. The key destinations for this turmeric exports countries are UAE, then followed by USA, Bangladesh, Sri Lanka, Japan, Malaysia and UK countries. So it is expected to be, we can reach to the level of $1 billion by 2030. So this is the target where we have to work on it. How we can increase these exports? The one is to get the quality produce in both the whatever, we'll talk about the chili or turmeric, that is the pesticide residue produce with quality. That is most important in case of horticulture crops. So if we'll see the value chain of this one here, in case of the Telangana. In Telangana, Nizamabad is having that highest, the biggest market area in Asia from Nizamabad only. So these are the Nizamabad, Karimnagar, Warangal, Adilabad are the prime districts where the cultivation of the turmeric is concentrated, 90% only from these 4 districts only. And there so if you'll see, these are the different varieties. I am not going to details of this one, like long duration, medium duration and short duration varieties are under the cultivation. So now if you'll see that long durations, most of them are having, they will give the high production, but the quality in terms of the curcumin content is less. Whereas medium and short durations were little bit low yield, but time it comes to maturity early, but having the high quality with the high curcumin content. So this is about, then If you see the major trading centers of turmeric in India, so in Telangana I told Nizamabad and Warangal main, that is a combined district of Warangal. Then in AP, Dugirala, Kadapa, of course Maharashtra and Tamil Nadu and Kerala, so and so forth. Here, so already I told about this is among these countries, you can target mainly the UAE countries, very easy because nearby it is hardly like 3 hours fly and there is a much more requirement, demand from these countries, so that we can trap. So here mainly, other states like AP and Telangana states, they are exporting this turmeric based value added products to Iran, Germany, China and Bangladesh, Sri Lanka and other Arab countries. So apart from this one, but apart from this, we'll see this distribution of the produce from primary to terminal market. So within the state also, from Telangana, AP, Tamil Nadu and Kerala to like, so markets they have found in the northern states, like from Gujarat to Rajasthan, like Sikkim, Assam to northeastern states, and Orissa and West Bengal to Chhattisgarh. So where the non-traditional areas, they won't get much produce. So these are the different forms of exports you can see. The first one is the polished rhizome, then powdered form, then that is the turmeric foliar resin, which is very important, that contains 30 to 35% of curcumin and 15 to 20% of the volatile oils, so which are useful in flavoring like meat and fish produce products and pickles and bakery and confectionery industries. Apart from that, essential oil is the another value added product. So where this volatile oil is derived by steam distillation of the turmeric rhizomes, so which contains fumaroles of 58% and gingerberrin 25%. So these have very value in preparation of different kinds of pharmaceutical produce. Then next one is curcumin. So the 95% of the curcumin powder form, which is daily, that is we are happy to say that actually during this COVID-19 period, so everyone is talking about how to improve the immunity. The one of the immunity based one is the found as a like a curcumin. You know very well that usage of this turmeric powder along with the hot milk, so which improves the immunity. So there is a much increased demand for this turmeric. Then turmeric pigmentation, which is used for herbal coloring and for different kinds of food products and cosmetics, antiseptics and so forth. So if we'll see what are the constraints in turmeric cultivation. So the first thing is non-availability of the quality seed material. Here the rhizomes are used as a seed material and the quantity is required in bulk, so the cost of the seed material is high. Then rhizome fly, then higher charges of commission agents and low market price. Whenever there is a produce is dumped price of the turmeric here, so where it has to be addressed. So some of the studies that are conducted at our university, that is Sri Konda Lakshman Telangana State Horticultural University. So this is the one that portray technology that can address the problem of production of the quality seed material or seedlings with low cost technology. So here splitting of the mother rhizomes, so that by sowing that one, which will give the quality seedlings with a vigor index and minimum number of taken for the germination and transplanting with low cost of production. So this is the actually how the vertical split of mother rhizome, so which will give early sprouting and we can provide at a reasonable price to the farmers. So this technology already standardized at our university and it has to be commercialized, and already the training programs are conducting at our turmeric research station at Kammarpalli to train about this technology. And one more thing is actually uses of the different types of organic manures, apart from like synthetic fertilizers, that is chemical fertilizers. Here, the usage of the FIM 45 tons per hectare with the ICAR microbial consortium of 1 liter, so which will resulted ultimately the highest fresh rhizome yield of 26.85 tons per hectare with the curing percentage is 24.71. Generally, we will get the curing percentage like 18, 19 to 20% in general, but here the recovery is highest. And the quality of the turmeric in terms of the curcumin content also it is high, 5.75, and foliar resin content is 9.25% with the anti-accidental activity of 12.01 micrograms per milliliter. So this is the one of the actually this related to the same vertical splitting followed by this planting, and this is the growth. There is no actually reduction in the growth because due to the splitting of the mother rhizome, and almost it reduced to the 50%, 1/3 to 50% of the cost. Then one more thing. So here everyone nowadays we are talking about the only organic farming. Is it really worthy? So if you'll see here the comparison between only using that organic farming, that means only FIM, vermicompost, neem cake, azotobacter, phosphosolving bacteria without fertilizers, it resulted in 24.23 tons per hectare. When compared with, if you are using in addition to that, 75% of the recommended dose of NPK, which resulted in 29.69 tons per hectare, and the curcumin content is 4.74%. Here I want to tell one thing actually, curcumin content is, it is improving with the uses of the organic manures, that is practically proved. And even foliar resin content also it is improving. So that shows the importance that we have to certainly go for at least minimum of 50% of the required nutrition through organic materials only. That may be either like your FIM or vermicompost, or we can combine with the biostimulants also. That's what. And she is my student only, Amala. So she did a nice work. And one more thing is uses of the different types of mulches here. So already proved that this black plastic mulch, this is the, whatever the technologies are maybe telling may not be new, but here I want to tell the implementation in the farmer's field, that has to be taken care. So which is missing. So we have technologies, results available, but to what extent these are reaching to the farmer's field, they are implementing. That is a big question mark, where this forum has to be addressed, that practical, the transfer of technology from the research field to the farmer's field, that is important. So by using this black polythene mulch, you can see there is a tremendous increase of yield of up to the 46.23 tons per hectare, almost 50% more, minimum of 50% to 70% increase in yield because of the control of the weeds and the effective utilization of the moisture and effective utilization of the applied nutrients. So that led to this increased yield. Then coming to the some of the innovative approaches apart from that mulching, INM, integrated nutrient management, already I told about, then integrated pest management. So these are the things has to be addressed apart from this improved that pro-tray technology to get ultimately higher yields. Then one more thing, here near in Siddipeta only, that is turmeric cultivation in protected conditions under the vertical farming. So Simply Fresh is the one private that organization which is cultivating this turmeric crop under coir pit with fertigation. So under greenhouse, this is like we can call it as a soilless conditions. So with this method, So they are getting in general, so around 700, almost 700 quintals per acre. When compared to the normal yields are like 100 to 150 quintals only. So this is still under the experimental stage, so they are practicing it, and maybe because of the more aeration and less incidence of the rhizome rot, as I spelled previously, so rhizome rot, rhizome fly, so that is the incident you can see. So that is mostly addressed with this growing this saplings under the controlled conditions with more of aeration using this coir pith and vermiculite. Maybe improve the water use efficiency, nutrient use efficiency, and lessen the incidence of the pests and diseases, and improve the yield. Then this is one more actually, that is the Smart Agro Food Park that was established at Nandipet, Nizamabad area. Smart Agro Food Park with the concept of Mega Food Park project. So it creates a sustainable agro-horticultural value chain with CPC and the primary processing centers and integrated cold chain network that connects these CPCs and PPs. So which was started during the year 2015 in 100 acres of the land and with the budget of 100 crores. And the production started from 2018 to 2022. So with the annual output of 5 to 10 tons of the curcumin. So as I said before, so after the COVID, the company is, so here because of the receiving the raw material is a high cost, so that because of the cost of the solvent and poor export, now little bit lower down, again it will pick up. So this is the curcumin extraction plant unit at Nandipeta, Telangana state. And one more thing I want to tell is, in Telangana, the most of the area is under the Armour local, which is a farmer's variety. So as a protection of the farmer's varieties, we thought of going for this one to submit to the central to protect this variety. And this is the commonly cultivated by most of the farmers. So this is the Nandipeta, that is the curcumin extraction plant. This is the Armour local variety. And if you'll see, what are the strengths, weaknesses and opportunities and challenges related to the turmeric to this one strength, our strength is actually our that agroclimatic and soil conditions are highly suitable for cultivation of turmeric. And this is the ISR Pragati is that is a short duration variety, very much suitable. I told that this is giving around 5.75% of curcumin content. Apart from this, NDH 98 Rajendra Sonia and Dugirala Red and SSC 79 also suitable. And we will see the opportunities for establishment of the turmeric based agro industries for like curcumin extraction and oleoresin extraction units. And if you see the challenge, the main challenge is marketing. So that is the marketing. This somewhat we had to concentrate on this one. This can be little bit overcome by using these FPO groups and with the tying up with the curcumin based industries where we had to work on it. This is the big challenge. And if you see that the future research priority to address this gap is, I told that high curcumin varieties which are suitable, those had to be concentrated, and developing this organic or INM, IPDM modules for turmeric, already it is there, and it has to be implemented in the farmers field, that is the one. Then what are the strategies to reach the farmers is, mainly genetically pure turmeric seed material that has to be provided, and encouraging these farmer producing organizations, groups to go for this turmeric based industries connecting with that production units. And this can be solved like by collaborating institutions with the ISR, and now of course I came to know that CTRI also involving other commercial horticulture crops like chili, turmeric and ashwagandha. So we thought of doing MOU with this CTRI in connection with to address these some of the things. Then coming to the chili, so chili it is in India is having the major share of 42%, and just I am presenting here, you can see that wide gap of the productivity between the China and as well as India. In case of the China, the productivity is 6,728 kg per hectare. So almost it is only 1/3 of it we are able to get per that 1/3 of it only. So what are the reasons? We had to work on it. So this is the weight variation of the chili, that the phenotypic, the genotypes overall available in India. We know that AP is leading in chili production with the 37.35%, followed by Telangana, Madhya Pradesh and Karnataka. Whereas if you see the productivity is high in Telangana with 3,945 kg per hectare when compared to the, so it is followed by that AP, that is 3,265 kg per hectare. Maybe the reason is because of that more humid climate, more prone to the pests and diseases. Just now we addressed about the anthracnose problem, then that is the, so which will reduce the quality and reduce the chances of export. And one more reason is uses of different kinds of pesticides, including fungicides, that may lead to that more of pesticide residues in the produce, so hindering the export of the this chili. So this is the actually fires area, then that area, and that is the productivity is 1.8 tons per acre on average, and this is per acre. Previously I told about that is a hectare, so don't confuse. So this is the chili area. So gradually it is increasing in between up to 2021. Again, because of the COVID and other reasons, and more because of the availability of the more water, most of the farmers shifted to the paddy cultivation from the vegetables, chili and other crops. Again, our government is concentrating as a part of the crop diversification to the other crops. So here, where we can see the scope of chili cultivation. Here I want to tell one thing, that is the identification and exploitation of new resistant genes. So that is the one in the breeding program we had to concentrate. Then integration of the molecular technologies and such as a marker assisted selection and genetic transformation. So these are the key issues in modern breeding program, and there should be emphatically exercised in order to develop better products of the chili. So here recently we have entered in MOU with the one of the private organization, that is Urban Kisan, which is working on the speed breeding of different vegetable crops like okra and chili. So where we are concentrating the most of the pest resistant chili varieties. So here, if you see the constraints, low productivity, climate change impact, and lack of good quality seed, and increasing the susceptibility of the most of the pest and diseases. Here we can, now the burning issue is the black thrips, so which we are addressing. Then high cost of the inputs and high labor cost. This is because of increasing labor cost, they are unable to get the labor to work in this field. So this is, so already several discussions are going how to divert the labor into the agriculture. That has to be taken in notice of the central government also. Then better post-harvest practices, especially like drying and cleaning, grading, especially drying. The proper drying is very, very important to reduce the moisture. One thing to reduce that aflatoxins during the storage, that is the most important. And one more thing is to maintain the seed viability as if it is a seed crop. So that is the one more thing. And and the ultimate is the marketing. So marketing has to be, if the farmer able to get a good quality, even a high produce, if unable to market to the for the reputed price, so farmer next year what he will do, he won't go for the cultivation of the same. So we have to how to retention the retention of the think of the retention of the farmers in these fields. That is the important thing we had to address. So here, use of the molecular markers in isolation of the resistant genes, sterility traits, so which has been proven previously already discussed in the different that breeding program, Dr. Anil Raichi. So this is has to be taken by the young innovative bright minds are here. Students, they have to concentrate on this one. And the integration of the traditional and modern molecular techniques would accelerate the identification of the novel genes for the improvement of the chili crop. So in case of the integrated pest management, this is the actually module that is developed in our vegetable research scheme, and I need not to grow all this, schedule. So here one thing is that Verticillium leccani uses in between is very important, and the another one is the neem oil. So apart from the all company based pesticides, so this is the schedule they have to follow, and optimum use of the pesticides is always advocated to the farmer. So this is recently, because of the black thrips, that is the thrips, parvis pinaceus and other pests, so this is the one more module that is developed here. So still we are working on it. Our team is working on black thrips, and one more is related to the storage. So this is innovative technology that is Purdue improved crop storage, that is PICS based triple layer hermetic bags are used. So one of the students conducted a work on this one, how to we can improve the storage quality of the dry chili by using this PICS. So by lowering that Aspergillus flavus infection. So this is achieved because of this modified atmospheric conditions of hypoxia and hypercarbia. I will show that picture of this one, PICS, triple layered one. So this is already used in case of the cowpea. We know that during the all pulses mostly infected with the most of the pests, especially bruchids. So the same, this is applied here also in case of chili. This is a triple layered one, and first they are infected with the Aspergillus flavus, then stored for about 2, 4 and 6 months. So 2 months, 4 months, 6 months, and there is no loss of in test weight and no change in moisture content and the quality also. So even recorded about 70%, 72% of germination even after 6 months of storage. So this is actually with our scientific team conducted a survey in different like Khammam and Warangal districts, different villages, and so this thrips incidence was noticed at different stages, transplanted, vegetative and flowering and fruiting stage. So irrespective of the stages, there is an infection was observed in different field conditions. And if you see the varietal susceptibility, so in case of the local landrace, that is Warangal Chapata, which is a famous variety, and that is rich in oleoresin and coloring agent and less in pungency, is more prone to this one. So this black thrips, and when compared to the spicy varieties, pungent varieties like Tejaswini and other things. So that is the varietal difference was observed. So this is the damage that has been seen. So here, so this is the how here one of the study that is weather-based IoT technology in the farmers field with the finance from that NABARD and Siri Foundation. They have conducted one study. Because of this weather-based, sensor-based technology that alerts that, so with that alert, so they, farmers could able to take as preventive measures, and there is a tremendous increase in yield and control the different kinds of pests and diseases. So already I told about this one. So this is our scientist, Dr. Anita, entomologist, principal scientist, along with the NBIR team, Sridevi and Rachna, and with local horticulture department officials have surveyed in Khammam, Warangal and Mahabubnagar districts, and which are infested with the black thrips, and suggested farmers to usage of the especially Pseudomonas and Bavaria. So as a biocontrol agents, rather than continuously spraying of the insecticides indiscriminately, which will somewhat reduce this incidence. So here, coming to the germplasm, just I am giving a look here. These are the different land races that are available in India. So if you are requiring the only concentrating on color, means Kashmiri chili and our Chapata chili and Mathania and Baidagi chili. If you are more of interested in pungency, you know that Bhut Jalakia is a highly pungent one, and followed by your Guntur, that is Sanna Mirchi, then dual purpose also, yellow type. So these are the different sources that can be utilized for chili breeding program depending on our objective and requirement. Because foreign countries like European countries, they require more of like colored with less pungency, but UA countries, they require of with a little bit pungent. So these are the things we can see. So then these are the different kinds of chilies you can see here. Here I am telling about Bhut Jalakia, which is having about 1 lakh plus like heart units, and whereas our other paprika type, they will have only 2,000 to 3,000, 4,000 like that. And Naga chili is again bird eye chili, and these are highly pungent type, and Jwala chili, Reshmadam. So these are the different kinds of chilies. I know that here Durgada Mirchi, still it is under the cultivation commercially. Durgada Mirchi, which is having much more demand in like Maharashtra and Delhi. Bear Mirchi, that is called. So this is the one we recently, last year in 2021 September itself, we applied for geographical indication of this Warangal Chapta chili, and which is having, that is from Timapet Chili Farmers Produce Company Limited, we submitted, and it is under the cultivation of 7,515 acres with the production of 11,660, and highly exported demand, having demand in foreign countries. The specific things is, it is having brilliant red color with 140 Asta units, and pungency is only 4 to 5 K heart units only, and it is rich in color and oleoresin, and suitable for pickles and local market, and it gives good quality if cultivated in the soils of like having rich in potassium and phosphorus. That is the reason it get that unique quality if it is cultivated around the United District of Warangal area. So these are the things where we have to address is to improve the value chain. One is the pest and diseases and their outbreak, and their monitoring with the traditional cropping activities, and digitizing the data. So here one thing I want to tell, we had to address is one thing, aflatoxins residue free material for export, price discovery and marketing. These are the challenges we had to work on it. And one more thing, production of the varieties depending on the requirement of the market, either oleoresin rich or color rich, that is capsanthin rich materials. So where we had to work. So here strategies to reach the farmers, how we can, that is already told previously, the market intelligence with ICT solutions. They have discussed the previous speaker with this, especially the orange with the sweet orange. So we are also with the Samhita, we working in the orange, sweet orange, like how to identify like digital accordingly that precautionary measures can be taken up before affecting the tree itself, and we can expedite the process of recovery of the tree and without affecting the yield. That is the one. Already our students as a horticultural industrial attachment, we attached to this Samhita unit in this case. So they are working on it every year. So the collaborative institutions, again now, sir, your CTRA also going to include along with this IHR and Dr. YSR HUNS and NIPHM related to this. Then the coming one is, this is the Ashwagandha. So Ashwagandha, because they told that Ashwagandha also CTRA is dealing with this one, and in India about this medicinal and aromatic plants are in the cultivation of like 499,000 hectares with the production of 926,000 tons. And these commercial medicinal crops that have potential to take up the cultivation, these are the Ashwagandha, Tulasi, and stevia, aloe vera, coleus, and acorus, and so on and so forth, Google and so here, if you'll see, in India, Ashwagandha is mainly cultivated in northwestern region of the MP, and more than cultivating about 5,000 hectares of the land, and also cultivated in Rajasthan, Gujarat, UP, Punjab, Haryana, AP, and Telangana. So here, these main, that economic part is root, so which will give that medicinal, that is very important, that powder is used to improve the nervous system and good for even diabetic patients. So if you see the how we can go for what are the feasibilities, so how opportunities we can exploit here in the Ashwagandha cultivation for this one. So here this crop gives that is remunerative returns from this root economic part, that is, and ease of cultivation even under rain-fed conditions. And this can be integrated with the traditional crops through crop sequence. And there is opportunities not only for the root and leaf, and seed is for like propagation only. So when we interacted one of the private organization, they asked for that seed production of Ashwagandha, they want to take up in a large scale. So this is how we had to exploit the private organizations who are taking up this cultivation of Ashwagandha. So we exploit those farmers, the private institutions, and linking up these private organizations with the farming sector. And value addition, so here mainly the current exports are limited to the export of the roots, and value added products has to be worked out in this one. So in Telangana, we have this, apart from Ashwagandha, Kalmeg and Coleus we are cultivating. So overall together combined erstwhile AP 1.88 thousand hectares are under this medicinal and aromatic plants with average production of like 3.5 thousand tons. So here, so we had to create awareness and impart the technical knowledge to the farmers and various stakeholders. So where we had to hold the handhold, we had to take a handhold of the farmers, then from the small scale to it has to be taken to the commercial scale of cultivation. This is the one we had to address. So this is just one of the study. So here by using only 50% of the RDF with 50% of the N through organic manuring, vermicompost. So the neem cake, so the recovery of the dry root yield is about 342.67 kg per hectare. And measures, I am actually, in the last minute I included this one, so I didn't collect the much of the actually data. Then how we can improve this one is, we had to identify the potential areas because it will come up very well under rain-fed conditions only. So wherever the unutilized or barren lands, that can be used for the cultivation of different kinds of herbs. And secondly, pertaining to the medicinal plant cultivation and marketing has to be addressed. So if you'll aloe vera, but coming to the processing, again farmers, they faced the problem. So you had to make a sure of the market, then go for the cultivation of any medicinal plants. That is the one important thing. So if in the last, so it is as a high value commercial horticulture crops, especially chili and turmeric, these two are having great scope and growing demand both in our domestic as well as international markets. So the key research thrust areas to be focused is this augmenting the productivity, because we have seen the wide gap between the highest productivity and lowest productivity, and the quality, processing, value addition, and the product diversification. Especially here we had to address to raise the income of the farmers, and how to improve this agricultural exports with quality produce, with sustainable agroecological conditions. And here, so one thing, three things have to be addressed, that is the sustainability agroecological conditions means, especially maintenance of the soil health. So we know that the organic carbon is reducing by like 0.33%. If you'll go for the cultivation like integrated or like a farming system, or else like a mixed farming system, you incorporating the perennial tree component apart from the annuals, which improves the organic carbon in the soil. That is the most important. Recently in the G20 summit, in that panel discussion, I suggested and contributed that like a minimum of like 20% tree component must be included in each farmer by the farmer in, so that will improve that organic carbon content. So which will ultimately maintain the health of the soil and improve the both the physical and structural of the soil, and it improve the growth and yield of all the cultivated plants. And apart from that, you know, improving that microbial activity by using the biostimulants. So since I am talking about from 2000 onwards, like usage of the K mobilizers, P mobilizers, but still we are talking that only, and we are recommending, but coming to the implementation in the farmers field is still it is nasal stage only, not up to the expected one. And where that is the one thing is the commercialization of this either biofertilizers and biopesticides has to be addressed. So made them available, that the quality material to the farmers is very, very important. So these are only simply talking about only the cultivation or improvement, and this one is one part, and the other one is the availability of that recommended materials or that that biostimulants or whatever we are talking. So to the at the farmers level, that is also one more thing is we had to see. So with these few remarks, I thank organizers, especially Director Dr. Sheshu Madhav Garu, for giving this opportunity. So one more thing, as a public-private partnership, actually we have entered a MOU with this ATGC organization, mainly which is working on mating disrupting technology, especially in control of the fruit fly of different fruit crops like mango and guava and sitafal. And they are also working in other crops also, how to like fruit, fruit and shoot borer in case of the brinjal they are in. So we are working on this one, and with this one our students also benefited related to this molecular and biotechnological based research, especially in horticultural crops, to improve, to get the quality produce with the minimal uses of the chemicals. That is the one.
Thank you, madam. Wonderful talk. Friends, you all join with me in giving a big hand to madam. Madam is the first VC among 71 agriculture universities in India.
Women VC.
Yeah, agriculture universities. Women. So you can, I think many of women scientists are here. They get motivated with your leadership and motivation. Because after madam, I think TNAU VC is the second woman VC has become in agriculture universities. And we can see, we already saw the great work of in turmeric as well as in chili and ashwagandha, of course. And we have a panel discussions today, madam. I think hope you are there in the evening, 5 o'clock. We have a great discussion on ashwagandha and castor. Of course, castor may not be your crop, but you can contribute. We had yesterday on chili and turmeric. Many of the points which you told has come yesterday. But actually, I tried to bring madam yesterday only, but somehow, as a VCs already have a lot of pressure in doing many of government programs and other things, as well as teaching. So, very good, wonderful, madam. And we will maybe having some questions, our people maybe will take in the later, because some more, we have 2 more sessions and we are running out of time. Thank you. Thank you.
Thank you, madam. I request our chairman, sir, to felicitate our speaker, Honorable Vice Chancellor, the first woman VC. I request our chairman, sir, to felicitate madam as a token of respect. On behalf of everyone, I thank our chairman, co-chairman and rapporteur for successful conduct of plenary lectures. Next we have parallel sessions in Hall 1 and Hall 2. In Hall 1, the session is on next generation technologies for information dissemination and digital agriculture, that is here. And the parallel session will be in Hall 2. The topic is innovative market interventions for commercial agriculture. So those who are related to innovative market interventions in Hall 2, they can go there, and the rest of them here, the session will be continued. Thank you. Let us break for 5 minutes and we'll start. Tea will be served here only. Tea will be served here only. I request all the delegates to please take your seats and take your break here. Tea will be served inside the hall. Those who are related to the theme innovative market interventions for commercial agriculture, they only can go to hall 2. The rest of them please stay here. We will begin the lead lectures shortly. Tea will be served inside, so please have your seats. For hall 2 members. And those who are interested to go to the hall 2, tea will be served for them there. And the hall 1, for the hall 1 participants, tea will be served here. Yeah, let us begin the lead lectures. I request all the participants to please. Yes, let us start the lead lectures. For the session 4, the title is Next Generation Technologies for Information Dissemination and Digital Agriculture. The chairman for the session is Dr. Neeraja Prabhakar, Vice Chancellor, Horticultural University. I request Madam to please come and occupy the seat on the dais. I request Dr. Neeraja Madam to please act as a chairman for the lead lecture session. Madam, please. Please come and occupy the chair on the dais, Madam. I request Dr. Anandita to give floral welcome to Madam. The co-chairman for the session is Professor V. Persis, Adikavi Nanna University. I request Madam to please come and occupy the chair on the dais. I request Dr. Anandita to give floral welcome to co-chairperson. I request the rapporteur, Dr. Y. Subbaya sir, to please continue the session. I request the participants to please come forward. I once again request all the participants to please come forward. And I request Madam to conduct the lead lecture session.
So once again, very good morning. Welcome to this session, Next Generation Technologies for Information and Dissemination and Digital Agriculture. In this one, so now the online session, Dr. Shivaprasad Kumpatla, on digital technologies in agriculture driving a paradigm shift. He is from USA as an adjunct associate professor, data science and bioinformatics, IUPUI. Please join.
He is joining, madam. Just 2 minutes. Dr. Sivaprasad sir, am I audible? Dr. Sivaprasad sir? I request the delegates to please come inside the hall. Those who are outside, please come inside the hall.
Okay. Yeah, and here it says it's not responding. Let me log out and log in again to see if that works.
No sir, you are audible. It is okay sir. It is clear.
Okay. Okay,
Please
yeah.
turn on your video sir.
Yeah, the video is not working, so I don't know why.
Okay.
To share your slides, sir.
Okay. Let me log out and log in again to see if that works.
స్నాక్స్ ఇస్తున్నా లేదా స్నాక్స్ ఇస్తున్నా ఏంటి ఏది కాఫీ లేదు లోపల ఇస్తా అన్నా
Can you see my slides?
Yes, sir, yes.
Okay, okay. I think some problem with the video, so if it is okay, I'll go get started.
Sir, just 2 minutes, sir. Sir,
Okay.
once again, welcome to the international conference. Today we are very fortunate to have the virtual presence of Dr. Sivaprasad Kumpatla, sir, advisor, agriculture data science, Carriosoft, USA, and adjunct associate professor, data science and bioinformatics, USA. Sir is having vast experience on molecular characterization of transgenics using next generation sequencing approaches, SNP markers and their impact on plant breeding, development of versatile gene-based SNP assays and genomics assisted breeding. Thank you, sir, for joining with us today. I request chairman to conduct the lead lecture session. Once again, madam, please.
Good evening, sir. Welcome to this session. Dr. Shivaprasad Garu.
Thank you. Thank you.
So, your lecture on like digital technologies in agriculture driving a paradigm shift. So, we know that actually in recent modern technology, we are talking on digitalization of each and everything, especially in farming. So, we are talking about AI and machine learning, especially in case of the agriculture crops and horticulture, that blockchain technology is very much required for the benefit of the consumer. So now I hand over to you, sir, please.
Yeah. First of all, I would like to thank the organizers for this opportunity to participate in this international conference. As the coordinators and the chair have mentioned, I'm currently serving as advisor for Carriosoft company. It's a fast-growing company specializing in agricultural data science for managing genomic data analysis as well as identifying variants for crop improvement as well as other life science projects. Previously, I worked as a global leader for data science for Corteva Agri-Science in Johnston, Iowa. So the purpose of this lecture is to give you a semi or high level overview of digital agriculture and how those technologies are helping us to move from traditional ways of doing things as well as adopting practices that were not possible so far because of lack of tools. Here is the outline for the lecture. I will start with talking about revolutions in agriculture and why we need a new revolution for improving crop productivity and to meet the global food production needs. I will spend some time discussing about the enabling technologies that are making the digital agriculture a reality. And then I'll talk about some applications. So I'll give you some examples so that you have a high level or good overview of what digital agriculture technologies can do. And then I will mention about some new and emerging tools that can propel us into agriculture 5.0. Then I'll summarize the talk and we'll go with question and answers. Okay. So we have gone through 3 agricultural revolutions before, and we are currently in Ag 4.0. The first one, as most of you know, so many people say it is up to 1920s. Traditional agriculture, it's a subsistence based farming. manual labor and animal power. So you know the traditional ways of doing things. And here, based on the statistics from, hello. So based on the numbers from US, actually one person used to produce food for 10 people in agriculture 1.0. In Ag 2.0, which is from 1930s to 1980s, utilizing the industrial revolution, mechanization and all those things. So the agriculture productivity has increased. And as you all know, green revolution is a major milestone and major impetus for agricultural productivity increase due to dwarfs and dwarf varieties, as well as applying synthetic fertilizers, pesticides and others. Then with the advent of biotechnology, molecular biology and other genetic engineering tools, we have a biotech revolution putting us in agriculture 3.0. And currently we are in agriculture 4.0. This is again driven by industrial revolution 4.0 because we have the availability of sensors, information and communication technologies, drones, robotics, big data, and many genomics tools. So people are calling this digital agriculture. So the next one is Ag 5.0. So which is going to build on agriculture 4.0 and also going to leverage several new technologies like digital twins, blockchain, IoT, and whatever new things are going to come out from artificial intelligence. So a little bit of introduction here on this slide. You can see the population growth on the left panel. So it is expected to reach 10 billion people by 2050. As you all know, on November 15, 2022, we touched on 8 billion people, and then anticipation is that we will reach around 10 billion by 2050. So to feed all the additional people, so we need to increase the production. We need compared to 2010 food production statistics, we need 56% more food. On the extreme right panel, if you can see, if we don't do anything, continue to incremental changes in the major food crops shown there, it's not going to be, we will still be in a deficit by 2050. So we need to do something in order to address that deficit. And here, the interesting thing here is that the population growth graph inside, as you can see, it's going to touch 10 billion or even maybe. And from 1860 to 2020, the corn production, and you can see the shapes of the curve of the population growth as well as the corn production, both are day-shaped convention. So the good thing is so far with all that time, anytime we had problems with the food productivity, we always came up with innovative approaches and tools and technologies to meet those needs and overcome those difficulties. But we have additional challenges to come. So here are some of the genomic molecular technologies that we have developed during the recent decades, like marker resistant selection, genome selection, multiple promates, and models with using the genotype biomarker technology. But these are not enough, considering the additional challenges like climate change, soil degradation, and decreasing arable land, and of course, building water resources and several other biotech measures. So we really need to address these while working on improving food productivity using multiple sources. And this is where the digital agriculture comes into picture. Many of you know, but I just want to say for the benefit of others who are not aware. Digital agriculture, I would like to define it as a suite of digital tools and technologies to collect, store, and analyze data and share data-driven insights and information to make to improve decision making so that we can optimize resources with minimal optimal resources we can improve productivity. And digital agriculture naturally touches the entire agriculture value chain. So I look at the influence of digital agriculture in three different stages as shown on the slide. Pre-planting, all the things we do before we put the seed in the ground, and crop growth during the process of the growth of the crop, all the things we can do, and starting from harvest and the processing and the storage, the transportation until it reaches the consumer. Digital agriculture is influencing and making a difference in all these different stages. So what are the tools and technologies that are actually enabling us to implement digital agriculture? I will go through the top sensors in a clockwise manner. Sensors for collecting information like soil moisture, soil temperature, pH, everything that we can collect using sensors on the field, including soil features and others, but also weather information. ICT technologies and cloud computing. Computing has made a tremendous difference because whatever we wanted to do earlier, we could not do because of low computing power. Now we have enormous computing power and still increasing day by day. And we have cloud computing available, so we don't have to rely on hardware that is located on the premises. Internet of things that are sensors or technologies connected to the internet, gathering information in real time. Blockchain for that can be implemented in the supply chain of agriculture. Automated robots for collecting data as well as farming operations. Big data and artificial intelligence is a big one, enabling us to analyze data to derive insights that were not possible to derive earlier. And remote and proximity sensing. The big data means a tremendous amount of data that is coming on a daily or hourly basis. So people look at it as a 5 V's, the volume, the huge volume of data, and variety of different types of data, and the speed with which it is coming, and the true tolerance. Artificial intelligence is a major player for data analysis. Under the umbrella of artificial intelligence, there is machine learning, and within machine learning, there is a deep learning that is being used for image analytics. And the natural language processing is another one that is helping us to work on unstructured data like the textual data, the chart box and all that is the chart GPT and all these things based on the natural language. Here is an example of what people do in digital agriculture. You collect the data using sensors or satellites or drones and everything. After collecting, prepare the data and then build a model using the computational tools and algorithms. And once the model is built, so you evaluate to see whether it is giving the correct input or not. For example, you collect satellite image data of crops and you want to see whether there are any spots in the crop area where there is a water deficit or not healthy like yellowish plants, things like that. And we keep on iterating this one until you have a model. Then once the model is developed and you develop an app. For example, with the smartphone, and that's how we build models for helping the farmer. Similar thing with using deep learning. Deep learning works based on neural networks, as you can see, it simulates how the brain works in the neurons and nodes and all that. Here, same process as ago, but the model building is based on neural network. Here the example is shown as it is looking at the picture of the number 2 and the input is taken into different layers in the neural networks, and at the end it is classifying that image as number two inside of the brain. That's how the deep learning works. And digital tools, analytics, artificial intelligence, not just in the field, they can be applied in the labs and applied in the genetic research, genomic research, and all that. So there are different methodologies available that can be applied for different applications for crop improvement. So deep learning, I'll show you some more examples. You already have seen how the neural networks work in deep learning. So another example. So we keep on using the input data to make the model better and better. Here I have an example of detecting an object. So if you're familiar with the self-driving cars, how it works, everything. Basically in real time, the cameras, sensors, lidars, everything. While the car is driving, they look at what's happening on the road, all objects, at last question, and the car maneuvers based on the object identification. There is another one, semantic segmentation, basically identifying each and every object within the situation of the scenario. And reinforcement learning, basically training them such that they get better and better. For whatever activity they want to play a game or handling some doing some projects. Remote sensing, the satellite remote sensing is making a lot of difference in crop monitoring and crop monitoring. On the top panel, there is a list of several different satellites from 1998 to 2020, and each one has a different resolution and rate or 0.319% resolution. So the satellite remote sensing works based on reflected sunlight from different objects, and that is captured and get that image back up to training the models. And the theory of the reflection is especially for the daytime of that is so that it is used and so remote sensing to measure the satellite altitude. And that optimal sensing is very close to the camera that has microscope small and I'll just quickly mention about the diagram and the system and very useful. Diagram I'm sharing a few applications of idea. From the genetic side and environment side, estimate order of is not as much, but very high in life to look at As you can see on the left side, the base soil is material close to the very material of the plant. But once the plant started using the remaining plastic material and which is the plant and then comes the right of it comes out. Using satellite images, we have mapped the species in the area of the last year that and then formation of the one these similar tools, you know, also come out and work in their community. On August 2020, when the big additional year of the we started the PDF problem use the satellite data, store and capacity. So, we are using satellite the cloud power. We can use the data of the cloud to directly. But if you are using the system data, you don't have to really get power. So here using the data created by the satellite and applying the machine learning we were able to see how the value of that into very knowledge the top and the below. Here is an example of using the interaction validation. Because getting information using the filter of one point better data, the local translation, and then in my house is data and that and that is the system that is passed on to your smartphone, and that is the collaboration. Here, using the machine learning based prediction of using the we can get from our system like 47 locations in all solid areas in that state. So it was observed that using soil network of the acquisition of nitrogen is very important. There is a nitrogen soil network and nitrogen that is very high population. Using both of the treatment because the high population and some of the systems that can often oxygen nitrogen like during these in the study of samples, we made the commitment to the medical science data into the model, and that is a very clear things that technology of people can do from the month, you can see actually back off the finance. And you can use the maybe the identity of classification in the classification of the if you are using actual and see how they measure and you can use the classification to identify as for example, the bottom right you can see a robot and there are looking at the problem and identify the maximum without that just like I talked about graph of thank you. There is one process and there is a real time
last one, I think about the maximum clear anybody different going forward, so in summary, I will give you the key from my job. And that's what I was thinking. So with that,
Thank you, Dr. Shiva Garu. And we can presentation of like IAR 1.02 of agriculture science zero. When we see how we can improve the productivity by interacting with the environment, practices in soil mapping, and green classification, like it's still used for in case of the IPL, better availability of. Thank you very much, person, from audience. One question. Are you really interested to the Dr. Shiva? One more question. Dr. Shiva, are you able to hear you?
yeah, I can.
Thank you. And Dr. Justice, Dr. Professor in the Department of Computer Science in University, Architecture and University, Rajahmundry. Thank you for an insightful and informative presentation. This morning we have another presentation by Dr. Nandi. Both of you have covered in a very comprehensive what are all the digital revolutions, digital advancements happening in agriculture. My point is when we are going to really enjoy this course, because as teachers we are teaching in the classrooms for students since years, we are teaching them machine learning, deep learning, blockchain, we are doing some power projects, classroom projects, but nothing is we are not able to see the fruit. The copy is not ready for yield. As our Prime Minister Narendra Modi has been mentioning, the last week a new campaign was started, Visit Bharat by 2047. It is no more developing nation, we are going to very ourselves as developed India. But when coming to all these ICT technologies and the interventions in the field of agriculture, I understand that we are still lagging behind. What is your take on this? Where is the gap? How can we move forward? How can we really realize this by 2047?
Thank you for the question. Actually, that's a great question. So, what happened is because of the initial investment on the R&D aspect of the technology, the first one, the first organizations to implement this technology are big industries and all that. Those who have a lot of money. But another area is how do you make them available for smallholder farmers or medium sized farms and all that. So lot of work is going on right now, and there are several initiatives. For example, in the US, there is a National Science Foundation. There are around 20 artificial intelligence institutes that are working on various aspects. Not only to improve the existing tools, but also how to make these tools available to smallholder farmers. Even for example, in sub-Saharan Africa, all these things are going on. In India also, there are several companies that are specialized in the satellites or drone-based imaging and data analytics and all those things. So they are also trying to reach out to the cooperatives or small to mid-sized size farmers. So next, the big task like you asked me is, so we have developed these technologies and we are applying them on large farms, bigger farms. But now we have to start looking at and implement ways to transfer this technology to different types of farmers also. So I think that is very, very important.
Thank you, Dr. Now, we will go to this presentation, which is very detailed now. And then Dr.
Thank you for the opportunity.
Thank you, sir, for your answers. So we are going to the speaker, sir. And in the last, the talk from Inaugural. Thank you, sir. So welcome, Professor P. Venkateswara, Director School of Computer and Informatics Science from the Indira Gandhi National Open University, going to present on role of artificial intelligence in agriculture. Welcome, sir.
Thank you very much to the state, and the offices for making. And first of all, I would like to thank the organizers of this conference for giving me this opportunity. From morning onwards, I was working all the presentations. There are two presentations for technology, who focus on technology. And I am also going to focus on the technology only. So there will be some overlap. However, one very important thing is that even after attending all the technology-based presentations, still we may not be able to understand some terms, because these emerging technologies still don't have a crystal clear definition. If you look to Google or anybody, you will see hundreds of definitions for one term. So everybody will be having their own interpretation. Secondly, I will try to focus on Indian education. So when I was thinking about application of artificial intelligence for the Indian scenario, that is the title role of artificial intelligence in Indian agriculture, that is the title of my presentation. Then I started thinking about, suppose I am the farmer, in what way I can use artificial intelligence to improve in every aspect. Then I could not really find the solution even now. There are many AI-based solutions, many things are there. However, when it comes to the individual farmer, they are unable to really AI. There are two major organizations which are using artificial intelligence and working on researching artificial intelligence for Indian agriculture. One is Google AI and another is World Economic Forum. So I'll be going in detail through the work that has been done by Google as well as World Economic Forum, and then the government organizations, IAR and other organizations. Then there were some mobile apps. So a mobile app may not be able to serve the farmer at individual level because if you share your own location, sometimes the location doesn't pinpoint exactly the place where you are. Then the net connectivity. So mobile apps give general information, but they are not going to help the farmer to that problem which he is facing. In one way, suppose I am a patient, then I go to a doctor. Doctor treats me and gives me medicine only for the problem which I am facing. What I found is that if a farmer is having an issue, or if a farmer wants to increase the yield or do anything, they are not getting the reduced technology-based guidance. That is the gap between lot of research being done and ultimately farmers really receiving the artificial. So as usual, I will be starting with the definition of the artificial intelligence. It is the simulation of human intelligence processes by machines, especially computer systems. Now, when one thinks that what is artificial intelligence, the easiest answer to say is that it is the opposite of natural intelligence. Okay, because it is very difficult to define what is artificial intelligence. So the best option is say that you know the opposite of natural intelligence. So say that that is the opposite of natural intelligence. Then what is natural intelligence? Okay, when I mean when I have to say infant or a newborn, when they are in the womb, they start learning. And once they are born, you find that they are starting the action process. Nobody starts. They start crying. They start doing several things which they did not learn. So whatever you got by birth can be termed as natural intelligence. But then what is artificial intelligence? To the best of my knowledge, anything you learn by joining the school, by observing the society, by your own experiences, they fall under the artificial intelligence. Because by nature, you did not inherit any of those. But once you are born in a society, you learn many things, you join your school, you complete your PhD, okay, you learn many things. So by joining, you are learning many things. So that is artificial intelligence. So the objective of this particular subject, artificial intelligence, is that how to make machines also behave like humans. But very unfortunately, the machines are not only behaving like humans, but they are behaving more than humans. If you take a computer, you tell it how to add 2 numbers or add 100 numbers, it can add in the fraction of a second. You can't do that. But you taught it how to add, but it can add faster than you. So that is your problem with artificial intelligence, that it overrides you, you teach it, it does learn things in such a way that you don't want it, you don't want it to observe. That's the reason why Elon Musk and other companies in the Icftca, they put on a regulation on artificial intelligence. European Union had already finalized the draft. We want to regulate artificial intelligence. It should not now happen. But once something is possible, there will be somebody in the world who will be using it for all values also. That is uncontrollable. So artificial intelligence is a simulation of human intelligence, but it is more than that. In AI, you have many types. One is machine learning. So it is type of AI which is focused on building computer systems that learn from data, enable software to improve its performance over time. In AI, you have many things. In the case of machine learning, you need tremendous data. You need huge data. Only then you can apply the machine learning. In machine learning, you will be specifically giving instructions to the computer what to do. That is your supervised learning. Okay? And then next comes the deep learning. I am running very fast in the types of the artificial intelligence because ultimately I have to land in ethical. Okay? So in the case of deep learning, it needs massive amounts of data. In machine learning, if you want good data, in deep learning, you need massive amounts of data. You need different types of computers called GPUs with around 40 GB, 50 GB RAM and other things. And only then you can apply deep learning. Deep learning is a subset of machine learning, concerned with algorithms inspired by the structure and function of the brain called artificial neural network. So we know that our brain is having billions of neurons. Okay, every neuron is connected to one another. So if a person under the violence, if he faces an accident and he has a head injury, based on the location of the damage of the head, some of his cognitive function will be lost. So the brain is having neurons in such a way that for each action you have corresponding collection of millions of neurons, and these neurons get connected. So in the artificial intelligence also, they are trying to model what are the artificial neural networks which will be executing and those algorithms fall under deep learning. So this is the theory about the AI. The different branches of artificial intelligence are machine learning, deep learning, computer vision, psychology, robotics, natural language processing, and export systems. In agriculture, drones are used even in the morning presentation. So they are using AI because they are recognizing the images and they are processing in the split of a second, which fall under computer vision. Then 2-3 days back, Russia started using the self-driven tractors for their agricultural purposes. This is called cognitive cognitive technology. There is one company in Moscow. They develop self-driven tractors. Basically, self-driven tractors are available since a long time, but now the capability of the self-driven tractor has increased tremendously. That is using artificial intelligence. And of course, I cannot run such 3-4 minutes video from there directly. In case time permits, I will directly running from there so that you can watch it. And 30 to 40 countries are currently using the self-driven tractor. Now, with the advent of AI-based technology, one thing is very important. Don't think that by applying technology, there will be unemployment. Okay? Because whatever AI-enabled technology is being used, that is basically not replacing the humans. It is only increasing the capabilities of the humans. Earlier, the doctor used to see the X-ray and he used to say that the person is having a cyst. Now, an AI-enabled software is looking at the X-ray and telling doctor that these are the problems that are identified, which his eye cannot really catch. So they are once again checked by the doctor, and then the doctor says that this is the result. So AI is basically helping the humans discharge their function more effectively, and in fact it is also leading to more employment because now you see AI specialists everywhere. So these are different branches of AI. Now, in the AI, there are 3 types. One is artificial narrow intelligence, artificial general intelligence, and artificial super intelligence. Because AI is being used since long back. I have done my post-graduation in computer science in 91-93. At that time, I have artificial intelligence as one of my subjects. However, the boom has come now because the AI needs volumes, and volumes started only now with the low-cost airlines where Icftca started giving 1 rupee tickets, and now you go to a hospital, it is full. Go to railway station, they are full. Go to airports, they are full. Come onto the road, traffic jams. Go to RTC, complete full. Now you have volumes. Since there are volumes, there is an AI boom. So artificial narrow intelligence. So in this, it is all over the place like Google. Google Map is using artificial narrow intelligence. Then we have ChatGPT, Bard, self-driving cars, Alexa, Siri, and other voice-based assistants. Then we have advanced algorithms that are used in many fields. Artificial general intelligence is like a computer that is as smart in all aspects. However, anything we can do with our brain, it can do, including the learning. So an AI algorithm doesn't behave in the same way every time. First time you ask it, it will give you answer. Second time you ask it, don't touch. Normally software means for every input, the output should be the same. You change input, output can change, but same input cannot have a different output. But in the case of AI, for each input, the output, because based on your input and its output, it will be learning which answer will be the better. The same is like a human being. I asked you a question, you gave an answer. Second time somebody asks you the same question, you give a better answer. That is how AI-based algorithms, they keep on performing better, but you cannot say 100%. Let's come to artificial super intelligence. Then naturally learn how to defy you also. Okay? So this is artificial super intelligence. The industry is turning to artificial intelligence technologies to help yield healthier crops, control pests, monitor soil and growing conditions, organize data for farmers, help with the workload, and improve a wide range of agriculture-related tasks in the entire food supply chain. I have already told you, Google is doing great work in Indian agriculture, World Economic Forum is doing great work in Indian agriculture, and another company that is working is Amazon. Amazon organizes seminars on AI, machine learning regularly, and they are doing great work in AI because whatever vegetables, etc., they are going to sell, everywhere they are using AI. They are having AI-enabled machines which will be taking away rotten potatoes. Okay. They are having completely AI-enabled systems. Every day they will be selling millions of goods. For example, in a search box, if you say that I am looking for red shoes, red is having a lot of variants. So the customers do not get frustrated that when I say red, it's showing pink. They want accuracy. So everywhere there are using AI. So Amazon is one company, World Economic Forum is another company, and Google is another. So AI and its role in agriculture sustainability in India. There are two projects which Google is doing. One is Antro Krishi and the other is Google Partner Innovation. These are the two teams at the Google. They are working on agricultural sustainability in India. So what they are trying to do is that basically whatever they have done, it will avoid the drought conditions. All of us know that once in a while there is drought in India also. By the work which they are doing, they are trying to avoid the drought conditions. Landscape understanding leverages satellite imagery and machine learning to draw boundaries between fields, the basic unit of agriculture, and essential in creating meaningful insights. With field sensors established, the model can determine the acreage of farm fields, forest and wetland areas, and can identify irrigation structures like farm wells and duck ponds to build tools for drought preparedness. So if somebody wants to start farming, they can give you specific information that what type of plants you have to put, in how much distance the plants are available, what should be the frequency, for the weather conditions, to what crop you have to go. All this information can be given by the Google for Indian farmers. So this is one image. I do not know. Yeah, it is very much clearly visible. You can see the boundaries there. Okay. So this is basically Google is having a wide advantage. It is having Google Maps. Okay. And it is in the search engine business since a long time. They have a lot of data with them. Due to that, they are able to quickly apply AI and are able to demarcate the areas like where there is water, where there is fields, what are the weather conditions, and they have years and decades data with them, weather. Okay, so 20 years back, in the month of December, what is the weather, they have accurate data. So they are able to harness on their strengths. Others cannot do it because others don't have data. They have to collect from others. But Google is having its own data. And due to that, AI needs data.
Since AI needs data and Google is having data, they are able to do great things and they are doing country-specific work. For India, from Indian agriculture, they are working. So this is one example where they are able to demarcate this particular area, and then they are able to give you a lot of information like even in a particular crop, if there are different types of bacteria, they are able to tell you that in your crop, in this particular area, this is the bacteria. That is the extent to which their research has gone. For doing the research at that level, it is not that just data they need. They also need high-resolution satellite-based cameras, which can really detect the bacteria in a particular plant from space onto the ground, irrespective of the weather conditions. So, high-level map provided aggregated statistics. Okay.
4 minutes.
High-level map provided aggregated statistics like area sound, normal rainfall, actual rainfall for the district, sub-district and village level. And Google is also developing landscape monitoring models which provide a more detailed picture of an individual's current performance and future needs. Future landscape monitoring models will be able to determine data like crop type, field size, distance to water, and crop loss or harvest date. See, they are able to tell by themselves when was the last harvest, because they don't ask the farmer. They have already taken the photos, they have the data. They don't need to ask a farmer to tell what is your last harvest, when did you start all those things. Everything they are getting by themselves. The team also hopes to provide in-depth data about farm ponds, information like water availability over the past month, year or 3 years would be critical in establishing water security and drought management strategies. So they can warn you 3 years before that there may not be water in this area after 3 years. So you have ample time to work in advance. Yeah, this is more clear picture of the Google AI segments, fields, tree crops and bodies of water. You can see different colors. You can easily make it up. The blue ones are lakes, they are water filled. Then you have the fields, there are demarcations, there are black spots, there are trees. And you have different colors. Each color indicates one particular feature. So this is the output of the Google system. They are saying that for the rice crop, they have told that it is 1.35 acres and all issues associated with it are shown, and it was shown for 2020, 2021, 2022. So future landscape monitoring capabilities provide users with in-depth information. And however, the impact of these insights extend well beyond individual farmers and empower India's entire agricultural ecosystem. Now, this is where the problem is. They are working for the entire Indian agriculture. So, if I am a farmer, if I need information about my particular 2 or 3 acres of land, where I am doing farming, how to get information from the Google. So they are doing for entire country. So somebody should interface between the farmer and them and provide the specific information to the farmer. Otherwise, if you go to a farmer and speak about AI, he doesn't understand. So this is where the link is missing. A lot of work is being done, huge data is available, but how the individual farmer will get benefited from it is a $1 million question. So I am quickly moving. The next one is World Economic Forum's Artificial Intelligence for Agricultural Innovation Initiative. So this is a project led by Center for the Fourth Industrial Revolution of India and the platform for shaping the future of AI and ML. The outcomes are, you must have already heard this software. One is Sagu Bagu, the other is Digital Green, one is AgNext, other is Krishitantra, and another is Kalgudi. These are the outcomes of these projects. But however, again the same issue comes that how the individual farmer will get benefited. So in the Sagu, you have 7,000 chili farmers enrolled, but however it should be more because the data may be old, and it will be giving you AI-enabled advisories, soil testing, product quality testing, and e-commerce. These are the features. So here they help in intelligent crop planning, smart farming, farm gate to fork, and data-driven agriculture. So some applications they help in preparation of the soil, sowing of seeds, fertilizer application, irrigation, weed protection, harvesting, and storage. At every point, they will help. However, how to get connected with them is the only issue, because they can help in every way. Like for example, if we have weather forecasting organizations, most probably they cannot forecast weather more than 15 days in advance. I think that is at most 15 days in advance, or in some cases it is only 2-3 days in advance. But here Google is giving you something 3 years before. So if I say that in this area there will be no water in the next 3 years, definitely whoever can take some precautions. So climate variables such as rainfall, temperature, humidity all have an influence in the crop production. Climate change is a result of increasing deforestation and pollution, making it difficult for the farmers to make judgments about how and when to prepare the soil, sow seeds, and harvest. So suddenly acres of forest is removed, the weather conditions change drastically. The farmer doesn't foresee.
Because of paucity of time, please come.
So I will wind up here. Thank you very much for your patient hearing. I gave my slides. Anybody interested can take them. Thank you, madam.
Yeah, thank you, Dr. Venkat Suresh Garu, for beautiful presentation on role of AI in agriculture. So how it is useful starting from its sowing soil to till the harvest and storage. So we will take up the questions in the last. One more speaker is there, Ram. Now I invite Dr. Sachin Suresh, Principal Scientist and Project Coordinator, Icftca Honeybees and Pollinators, Division of Entomology, ICAR New Delhi. He is going to present on ecological importance of pollinators and their conservation. Please, sir. So I invite Dr. Murali Krishna Garu, Professor NIFTM, who is going to present on exploration of nanotechnology in agro-ecosystem and rapid sensor development. Welcome.
Sir is working as an officer in the Department of Basic and Applied Sciences, National Institute of Technology and Entrepreneurship Management, NIFTM. His expertise area is condensed matter, physics, material science, and sensors. Sir, please. You allocated time of 25 minutes, followed by 5 minutes discussion.
Good afternoon, everyone. Thanks to the organizers for giving this opportunity. So hope everybody is feeling hungry, so I have to wind up quickly. So I know your condition. So I am Dr. Murali, came from NIFTM campus. Of course, I am associated with Rajahmundry, but I am working at this NIFTM campus. And of course, I am long back associated with this ICAR-NIRCA also. So thanks to you people for giving this beautiful journey for these long years. Of course, this NIFTM campus is established by Ministry of Food Processing Industries, MOFPI. And particularly, this institute is working for the food safety quality and as well as the post-harvest technologies development. So this is the beautiful campus. The specialty of our campus is, along with the academic program, we have the pilot plants If any farmers they are interested, they can come there, they can develop the products there. And along with this one, we have the FSSA lab, Food Safety Standards Authority of India. So if anyone wants to do the testing with an NABL lab to launch their product, they can do the sample analysis. So this is my talk where I am going to give this nanotechnology based agroecosystems. Okay, so rapid sensor development. Of course, this talk is a little bit different from the morning topics which we are listening, and you will find a little bit difference also. We are doing the back-end analysis. That means how the detection is taking place. Okay. And of course, here who are the students, they may take this interesting work if they are interested to develop their career. Hope this nanotechnology details are already we are enjoying. These fruits are already available. Okay, we are regularly watching it. But just I'm giving the background of it. So what is basically a nanotechnology means? It is a tuning. Okay, materials tuning, material properties tailoring. So any size of the material, of course, any sample will have the 3 dimension. We call this as bulk material. So from bulk material to, if you reduce the size of the material to 1 to 100 nanometers, then it's a global definition. The size of the material should be reduced to 1 to 100 nanometers in any dimension. Then we call this as nanotechnology materials, so nanostructured materials. So I am coming from the right end where you are seeing the 3-dimensional materials. Okay, they are 3-dimensional materials. So they are polycrystalline forms, liposomes. So they have in all the 3 dimensions maybe 1 to 100 nanometer diameter. And from there, if you come to this 2-dimensional, there are thin film structures as well as graphene structures. Okay. For example, if you coat any substrate film, then it will be a 2-dimensional material. Then 1-dimensional material also, we call this as carbon nanotubes, CNTs, and of course nanowires. And it is a 0-dimensional. So excellent photocatalytic properties as well as optical properties will come with 0 dimension. So why this nanotechnology required at this moment? Okay, why we should switch over to the nanotechnology? What advantages it will give means this is the answer. So of course the scientists as well as government agencies they have a lot of responsibility. We are looking this by 2050. The population growth is taking place by 50 million. Okay. So then whatever the food safety security as well as decreases in the arable land that we need to face it, these challenges. So of course the government is making these agendas also. And today my presentation is mainly focusing on these three, which is related to the agriculture side, that is nano-fertilizers, nano-pesticides, and nano-sensors. Among these three, already we are enjoying these results also. Okay, one by one, just I am going to quickly wind up these things. So first of all, coming to this nano-fertilizers, and of course this nanotechnology is basically applying in this many kinds of different areas in agriculture. So since morning people are telling we need big data generation for IoT, from where this data is generated, how it is coming, okay, without human interference. So this is the technology which is generating, and of course at the end I am going to give you how the data is going to interact. Okay. So we have these kind of different stress, that means with application of nanotechnology, we have this stress tolerance, okay, soil enrichment with nanomaterials, crop growth, crop improvements, okay, then crop production. So many locations this nanotechnology is going to revolutionize the things. And of course, why this application of nanofertilizers and nanopesticides are required means, particularly this nanopesticides, this is nanofungicides or nanoinsecticides, okay, herbicides, okay, nanobactericides. These are the highly applicable with very less quantity. That is what just I am going to show it. And of course, nanofertilizers also they go a very different application point of view. So this is the major difference between this conventional fertilizers as well as nano hybrid structures. So in conventional, of course, you have to use very huge fertilizers, okay, as well as pesticide sprinkles also. But whereas in nano, everything will reduce because the why this differentiation is coming is because the increase in surface to volume ratio. So that's why the properties are very highly tunable. Okay. So first of all, definition of the nano means 1 to 100 nanometer size. Once the size is reduced, the surface to volume ratio going to increase. So that is the major chemical catalytic properties going to change. So that's why they show this smart delivery systems, okay, loss reduction and plant resistance, improving the plant growth. So whatever the agricultural field is required, okay, to get the good yield, good quality product, that will be given by this nanostructured materials applications. And of course, this is the change. Of course, at the top you are seeing that there is an expansion and scalability, which is very high risk zone. If you come with this nanostructured materials, it is withstanding with these types of stresses like biotic, abiotic, okay, nutrients, salinity, water, drought, heat. So today, whatever the challenges it is coming, everything will be controlled with this nanotechnology. So once these green systems are applied, then you will find this improving in this stress suspension. Okay, so more precise targeted deliveries, these things can be done. And along with that one, we have the farmers always look for the economic growth. So that can be achieved with low cost inputs. So now after this agriculture, finally the product should be utilized to the consumer. Okay, whatever the agriculture product that should come into the hands of the tables, okay, that is the only application we need. So that's why this nanotechnology is useful in this smart food industries also. So there are so many. Regularly we are doing this work at our labs. Okay, particularly my lab is working on this sensors that I am just going to show it. So this is nanotechnology for the smart food industries. Of course, this kind of packaging materials are already available in the market. You can go and see it. Okay, that will be useful in this preservation or the food functionality, nano food safety, food packaging. So we used to say it is a smart packaging, intelligent packaging. So this kind of things are already available. So now, how this functionality can be achieved? Okay, once you have the nanostructured materials, how this functionality can be achieved means many things can be done with this encapsulation methods. Okay, so you may apply the nanostructured material directly, or you can do this with encapsulation, because the property has to be sustained. Once I am delivering the nanomaterial, whatever the material property I need there, that should be sustained. Okay, so to sustain that property, I need to encapsulate. It's a protecting layer. So with that protecting layer, it will go and deliver to the plant. So that is the meaning of this slide, what you are explaining it. Okay, so here it was shown that it is a polymeric nanoparticles attached with this biocides. So they were delivered to the plant. So right from this leaf, which will be mostly applicable with this photocatalysis as well as depositions, erosion, evaporation techniques, controls. So everywhere it will be useful for this encapsulation nanomaterials. Then what are the advantages of this delivery of agrochemicals using this nano carriers? Okay, so this is the thing how the pros and cons which are available with this nanostructured materials. And there you are seeing this nano fertilizers. Mostly we categorize with these three, which is action based, nutrient based, and consistency based. So with all these three, farmers will get a good advantage once they apply this kind of nanostructured materials. Okay, so they will improve the shelf life. Okay, they improve the stability of the crops and high diffusion rates and less exposure to the agrochemicals at the end of the users. So these advantages you will find. And of course, coming to this slowly the materials, okay, you may have the doubt why this nanomaterial, what kind of nanomaterials we are using. So these are the list of nanostructured materials with different areas of applications. Okay, if I need a pesticide, if I need a fertilizer, if I need a nutrient, micronutrient, you can select any of this kind of materials. It may be organic, inorganic, or biopolymer type, or carbon-based materials. You can see that list which is given. Mostly the gold nanoparticles they will be using. Even this gold nanoparticles they are using in the medical area also, and iron nanoparticles, zinc nanoparticles, then silicon nanoparticles, multi-walled nanocarbon tubes, carbon nanotubes. So that right side is showing the material particle, how it is implemented, and it is showing the targeted delivery, and finally it is giving the sustained release. And that bottom one is showing the characterization techniques. Once the nanomaterial is designed, we need to characterize whether the properties are achieving or not. So after that, this is the thing what it is explained that A, B, C, okay. So from A, that is the first of all design of the nanostructure material with a particular specific functionalities. Then it is the size dependent transition. So we may get the doubt once the nanostructure material is available, how it is delivering to the plant. So it may through the leaf or through the roots, anywhere it can penetrate, and based on that cell size to that cell wall junction. So you can see that increases from the 0.1 nanometer to the 1000 nanometer, the particle size, and where that penetration through that external cellular spaces, cell membrane, occurs, stomata, all these things, how that will give the delivery of this nanostructure material penetration and entrapment, it will give that functionality can be observed. So finally coming to this C, it may be foliar type, okay. So it may be trunk or root, wherever it is applicable you can do. And that middle one is showing that how this through from this epidermis to xylem, that will be penetrating with this nanostructure materials, that was explained. So this is again the same, how the nanofertilizer applications will take place. And this is through the roots, okay, through the roots how this nanoparticles will take place. And of course here just one word I can say, generally these plant roots may have the negative charge, where you can design the nanoparticles with the positive charge, the bindings may take place, and it may penetrate through that cell membranes. Okay, so this is the root, how this will take place, right from this root hair to protoxylem. So that is the location how it will penetrate with the different nanoparticles which are iron, zinc, cerium, okay, C70, fullerene structure, or copper nanoparticles, titanium, nickel nanoparticles. So this is one of the, I told in the beginning, we are already enjoying. This is an example of this nano urea, which is already developed and it was in the market today, farmers can apply it. So this nano urea, it is comprising with this nano-sized nitrogen particles, and this was released by our Honorable Prime Minister. So this is in 21 initiation. Okay. So the miracle of this particular nano urea is, nowadays people are using this urea which is a 46% nitrogen. 50 kgs bag, it is equivalent to 500 ml of a nano urea bottle. Okay. So the change is tremendous. You can visualize it. Where that 50 kgs, and of course it will reduce the transportation also. So if I want to send some 1000 bags of nano urea bags, and where I can send the 10,000 bottles. So the logistics will also be tremendously is going to change. Okay, and of course the cost effective also. So it is from government side, the subsidy for the fertilizer as well as for this farmers also. So there is a huge differentiation which is observed already with this nanotechnology. So the bottom the graph which is showing the changes, okay, fertilizer subsidy which is going from this 2019 to 2023, it is going on increasing. Now with this application around 15,000 crores for this subsidy, fertilizer subsidy, it is going to be reduced. And besides, not about the money, environmental friendly, okay, you can see a lot of degradation in the nano urea with this utilization. That is a patentable product. Of course, India is the first of all developed this nano DAP as well as nano urea, and now this nano urea probably saying we are giving to the USA also. Okay, US FDA they taking this. So this is the you can see the quantity how much it is using. Just it is a 2 to 4 ml nano urea per liter of the water. This is the quantity which is just used. And of course this nano urea it may be used with neem urea also. And just it is just spraying in the early morning. It changes the whatever the required that 50 kgs of bag it is utilized. So here it was given cost of this bottle is only 240 rupees, where that bag cost is around 3,500 to 4,000 rupees. So that is how it is changing, not only the money and the utilization also. Okay. So of course it is giving the green technology. Again, this is with nano DAP, how it is changing. Even DAP also it is liquid material, which is at 600 per bottle, 500 ml, where this DAP bag, it is at 1350, which is a 45 kg bag. Okay, this is the differentiation how the nanotechnology is bringing. And of course, this is one of the Egyptian technology. Okay, they are developing it. So farmers, if they are interested to develop their customized design for the fertilizers or the pesticides, now at the farming location itself that can be done. So that is the design, okay, prototype design, which is going to develop. Okay. Now after that it is the pesticides, same like fertilizers, pesticides also showing a differentiations with these nanostructured materials. And of course, during the delivery, one of the things which scientists has to take care is pH. Okay, so where the alkaline to acidic zone and the primary nutrients, secondary micronutrients, they will going to affect. Whatever the green zone you are seeing in this pH delivery, that is the thing we need to take care of during this nitrogen, phosphorus, potassium, zinc, iron, where they have to deliver. So after that, now besides this zinc, calcium, whatever it is, people are thinking, why can't it is a multiple delivery? Why it is only zinc? Why it is calcium? Why it is nitrogen? So now it is innovative technology, which is nano formulation with encapsulating the pesticides. So you can see that buckyball structure, we call it as buckyball structure, where it is containing this calcium, magnesium, and as well as aluminum, okay, or copper, at your interest. You can tune that material, and that multiple properties can be delivered with a single particle. So the graph at the bottom it is showing with the pH, the release rate. Okay. So at a particular level, as shown in this previous slide, pH it will tune it. So and of course you are seeing that yellow colored and blue colored hexagons that is showing this pH responsive closing and opening. Okay, I can tune the material. This is called properties tailoring. With pH tuning, I can tune my properties. So this is nano pesticides, how it will be delivered, how it will function with this plant when it was improved. So with this cell, how it will interact with this nano pesticides. So now coming to my area, after that fertilizers and pesticides, this is the sensors. So right from morning you are seeing the sensors, big data generation, everything will be required. But how the sensor will function? What is the block diagram of that sensor? So at the bottom you are seeing a specific analyte is required. Okay, anyone, we need to be detected something. Just we are seeing this slide with our eyes. Same way, I need to detect some micronutrient or some adulteration or some pesticide residues, antibiotic residues in some product. So that is my analyte of interest. So that analyte of interest will be binded to the specific target, which is binding material. So at the bottom I am explaining it. Then it will go to the transducing material. So transducer means it will give you the functionality, chemical or electrical or optical change. Then it will go to the output. So output will give you the signal. This is how the sensor will generate. So this array of sensors is generating the data for the further computational technologies. So this is the thing what I told.
Please conclude.
Okay, madam. Just it is ending. So this is the thing how the sensor will go. You have the analyte, then you have the reference transducer, then electronic digital technology which is going to display it out at the output. So you have electrochemical, optical, thermal, electronic, gravimetric, or acoustic technologies which is going to detect it. So these are the different sensor technologies which are characterized. So of course today in your even in my lab also we have this chromatography techniques. So one chromatography technique if I want to establish needs 2 to 3 crores. But today the sensor technology is going to replace. What is the advantage of sensor technology? Means low cost. So I think I give you a simple example. people who are diabetic, they may be using the diabetic kit, okay? So that kit will contain the glucose oxidase peroxidase, which is going to bind the blood glucose. Then it will give the signal at the output. So the simple test will give on-site detection. Even today you go to the market, you purchase a food product. So if the food product is something having adulteration or fungal growth, something which is health problem, then you have to detect it on-site detection with your Android mobile itself. So that's why it is the advantage how you are going to detect. It's a real-time detection. So these things morning people explained it. Of course, this is the people are using the formaldehyde for the shelf life enhancement. You can detect it on-site detection. Now another revolutionary technology is 3D printing. In sensors, even my lab, we are doing this 3D printing technology, which is low cost. You can tune the materials. So along with this polymer materials, which is called filaments, so there you are seeing the printing, that is filamentous technique. And along with this, you have the technique of detecting with this banana spoilage monitoring. And of course, this is the exact technology, how we use the electrochemical technology. So this is with chili, rhodamine B, which is adulteration. It can be detected. Even in my lab, we are doing it. And of course, we are detecting this molecularly printed polymers also, MIPs. And morning I listened one question, is it possible to detect the secondary metabolites? We done that, okay? And of course, we are giving to the NDDB, National Dairy Development Board, where the aflatoxin B1, B2, G1, G2, we are finding it. That will be converted to M1 also. So this is the aflatoxin detection. And of course, this is my paper which is published, okay, where we done this NDDB paper release. We are going to do this. Yeah, finally my conclusion is this one. Of course, now if you see anywhere, anyone who is starting or interested in the food sector, they have to go to this fast course, which is FSSA. From November it was started. So these are the fast course FSSA licensing techniques. And APIDA, if anyone going to export the food sources, this is the requirement mandatories. Of course, at the end, why I am showing this slide is, we are using the nanotechnology, but whether it is good or bad, still it's a big debate. And even this FSSA, DBT, the National Biotechnology Department, they are all designing the regulations. These are the regulations. So there should not be any issues in that. Okay, thank you. So if anyone interested, you may contact me. We are at the NIFTM. Thank you very much.
Thank you, Dr. Krishna Garu. Very useful topic, both for farmers and as well as faculty and scientists. So we will keep the discussion at the end, sir, and we will invite the next speaker online. Dr. Sachin Suresh, Principal Scientist and Project Coordinator at ICAR-NIRCA, Honeybees and Pollinators Division of Entomology, New Delhi, IRI, and ecological importance of pollinators and their conservation.
In the meanwhile, if anybody is having any queries, they can interact with the previous speakers before the online speaker connects.
Is yourself and specify the speaker name to whom you have to.
To that speaker just spoke. So it's a very interesting lecture. We are interested in developing sensors for pesticide monitoring. Yeah, pesticide residues. Because especially tobacco, we need to reduce the pesticide residues. Okay. So different types of pesticide residues we want to estimate. And for that we need whether we can develop a sensor.
Yes, sir. Just for your information, I am sharing it. Before coming here 15 days back, Amul company people came to my campus, and their requirement is also pesticide residues detection. So till now there are no in-house. That means within India any sensor is there. So what are the sensors we are going to take? It is from US or some Germany somewhere. So that's why this Amul people they came. And they have a list of 28 pesticides which is going to detect. So we are doing this project. Along with the pesticides, we are going to do this antibiotic residues also. That also we are doing for Amul. And if
Recording in progress.
If you people are interested, we can extend the support to you also. 100% you may come to our campus. Okay? Sure. Thank you.
The population, many of the crops might lose 90% of the Overall, for I know around there are around more than 20,000 efforts especially for more than out of that 800 are in India. And animals as a whole, to pollination, they contribute around $527 billion globally every year. And out of that, insects they contribute around $161 billion annually. And there are so many exploited species, not the honeybees we are using for pollination. So many species of exploited bees are also there. And they contribute around $3,251 per hectare. And there are different methods of these pollination, flower based, and speaking examination. So when the transfer of pollen from ancestors to my main flower, that we call it as a scanning. Then it happens from one flower to another flower. On the same plant, we stop because of that. Otherwise, if the plant, they are different. And many times the cross pollination can be created so that there should be open pollination by which you should get. Yes, many times flower never works. So there is no chance for cross pollination, then only same pollination happens. Then there is homogamy when the matching of central pollen happens at the same time. So pollination will be, there will be self pollination. Likewise, there are conditions where the self pollination can be prevented, like insexuality, where the male and female flowers are present on different plants, like we see in papaya. And maybe for compatibility comes into there, and many times they will just look at the flower, where the flowers open, and which at different times. So there is a need to take for the cross pollination. So, there are the iron that you will about among the cross pollinating factors contribute to 90% of over the 90% of the cases. Where we see pollinating by insects, bats, snakes, and birds. And by the factor, there are always the factor which is to wind and water. So, where I have given our Icftca, but there are predominantly 6-7 orders which have very active pollinated, like Anaphyllus, Dipterus, Leptophilus, Coleophyllus, and Pachynophilus. So among the different types of bees, we are, as I told you, we are having mainly 4 types of bees, Indian bee, then the Canadian bee, the bee, and the drum bee. But any of the species we can take over as a lot of demand all over the world, and it is increasing population, which you around 4,000 rupees per kg. And recently there are vitamin antibodies in India and distribute. There are so many versions of vitamin D available, but we have one for vitamin D that is very present in Africa, because it is in 1965 it gets shipped to different parts of the country now. And with specific pointed out to cities and the pollination in different food crops, we have to crop, we can see there is very good case with water fertility in the bee pollination. You can see like a dragon fruit, which the open pollination is more easy, but still it is bee pollination. There is very good in like you see the muskrat, with the use of bee pollination, you can increase the impact to 50%. And there is always a really good case for the pollination from the food crop. We use normal species of the bee, but in mango, the house flies are the predominant pollinators. If we don't have house flies, then the mango pollination is gone. And like you see the support of fish, which are always but they contribute a lot towards the pollination. So no species is bad or good species. All the species they are right to grow and they are performing their duty. The bumpers which like honeybees they do not work early in the morning and late in the evening, but bumpers they are very good to pollinate and they work throughout the day. So with respect to the some of these we have carried out the pollination in for actually cross pollination crop and many times we use the varieties which use good quality pollen. So those varieties are called as pollinators. So you can see when we have taken the colonies, pollen influencer and without pollen influencer, right from 25 meters to 100 meters away from the colony. The colonies which were near to the targets which were near to the colony, they gave very good food taste percent compared to the colonies which were far away. And you can see this is green. The green is good pollinator, they give around 60 tons yield on the pollen per hectare compared to the these with pure pollinator or without green pollinator and without green with poor pollinator. So many of the companies took up the role of pollinator must and it should be controlled. Like in India also you can see the food taste in bee pollination can be increased by 62% as against the 0% in central pollination and 13.65% in open pollination. So in Sarak Mukubar also we have very keen relationship with the bumblebee varieties there for the pollination, and you can see here the number of seeds per foot, though it's more in open pollinated case, but the seed yield of pollen, the yield or the rate of the pollen seed was very good with respect to the bumblebee pollination. And likewise, you see the percent food rate and then the percent single food was very good with respect to the bumblebee pollination in Salag. And you see under tomato, when you are in the green bumblebee, the mean food rate, the yield was found very good, that is 12.7 kg per meter square, rather than 26 or 6.86 kg if it is to control. And reports were also very good with the bumblebee pollination. So especially under tomato, when we are using seedless, they are they don't have the seed, but they are modified that 90% white. And you can see here the food taste percent, food rate, food yield, pH, seeds per food, all were significantly more with the pollination. And we are using the carpenter bees, they are here spider, but they are very good pollinators. We have worked out the machine structure culture for its conservation. So rating the bee growth can increase by 250% over the control. And culture bees, if you like it, these pollinators and establish their role in the pollination. Though the green food rate, green food rate and everything was very good with the pollination pollination, but still role of this cannot be negated. You can see that if bee was visited for a single time or two times, three times, four times. So the meat food rate was considered was found to be considered. So in mango also we have established the role of industry, and you can see the pH percent went up when they were pollinating the industry. And we can certainly give the industry for mango pollination. And but as I told you, this is one of the control. In cucumber, we have established the role of industry for pollination. We put yearly industry pollination probably 61% more yield compared to the control. And you can see in the next slide, cost of production also was less with respect to the pollination industry. Otherwise, in the normal pollination, we used to pay for more labor for hand pollination. So, very big cost was also very good with respect to industry pollination. So, cotton is also important for commercial crop, and with the addition to mixture. Earlier, our big flora of the honey production used to start from October. With the introduction of the cotton, we get the mixture from cotton beginning September to November. And there was a case for open bee pollination. So the speed with respect to bee pollination and open pollination was very good compared to the pollination exclusion. And many of the companies they are supplying colonies on range which is to carry out the pollination. This is one of the companies that plays for India on the crop on implement in Maharashtra and United States. And you can see that cook side, the bee in touch with the pollinator was found more resistant to the bee pollination. So dragon fruit is is a new commercial crop which is coming up every day. And the hand pollination is still giving a better result in dragon fruit. But still the bee pollination was found better than the open pollination, which gave 19% more yield compared to the open pollination. Apple has already discussed you, it is a corporate crop and needs very good pollinator varieties. We have established a very good structure for the Indian honeybees so that they can pitch and be generated in other parts of India. And there are very good pollinator varieties, so we need to choose them wisely if you want to carry out pollination in apple. So we can use the pollinator varieties as a mixture in between, or we can use them in 1:1 ratio, so that we get very good pollen of each other varieties from the fertilization. You see, we have also worked out what to do the two times when we have to keep colony length, how many number of colonies we have to keep per acre, so that we get very good quality and quantity of seeds. So honeybees actually share the photosynthesis to do the pollination, but they use the pollen also. So we have designed the very good pollen trap, and we can collect the very good quality pollen from many of the crops. So here you can see from mustard we can get around 600 kg grams of pollen, as well as the 100 kg per gram in the sunflower and 480 grams in nylon. And the pollen cost get around 15 to 20,000 rupees per kg, and it is very good source of even food. So we can get added advantage with these. Bees, they collect the nectar, and they can nectar attract the dangerous pathogens. So what they do, they collect the nectar from trees, and they get the student because of city mold. So this is also one of the essential services which can be given by the bees. And these basic quality, but at the same time, we can disperse the biostimulation. So we have found that in home food, but the pollinators like the aphids, it can spread from the that is physical bacterium to the cellulose, and we can control the spider in home food. Likewise, in strawberries also, what it is infection can be reduced by using the normal means to vector the viral composition. And all these we can achieve, but our ecosystem is in degraded state now due to there are lots of loss in climate change, there is too many pesticides, and there are other engineering species. We are constantly going for this weeding, and many times the weed flora is using very good quality and pollen too, and it is another point. So honeybees are dependent on us because many of the plants which we grow, we give them different type of resources, right? Honeybees, they make the cavities for their queen. And in bumblebee, they construct the nesting site in rodents and mouse nest. So normally it is very good feed the rodents, we have to feed them. So with those, we fill a good burrow, and bumblebee they cannot do. Likewise, they are dependent on us and their habitat destruction. So how we take care of the biodiversity, we use crop to basically minimize use of pesticides so that it doesn't affect the pollinator. And there should be better land because better land gives the what we call access for the nesting. And many times we need to go the flowering angle so that we get the growth of we get the nectar and pollen from the flowering plant. And we have designed many of the nesting blocks which can be installed in the field so that many of the fertility we can live there. And whenever you have trees, so go for the trees which give the pollination like family, we have system, then we have very common, we have. So there are so many trees which use the current pollen. And same time, there are the trees that is like that is not cut here because as I told you about carpenter trees, they have a nesting structure for the many of them. We need to have water sources, so that many of the pollinators depend on the water source also. And next is we need to conservation. Second, actually, actually, those that are being used as volleyball activities, community cities, in Nairobi forest in the work. And I mean, normally what they do, they just kill those colonies. They collect honey and they sell out in the market, but the quality of honey is not good because they don't have advanced commercially processed that honey. And in that process, we are losing many of the colonies. Like we have lost around 25,000 colonies last year. And what we have done now, we have started giving the code and we have started giving, we have given the training. And last year we have got around 100 researchers into the scientific meeting. And very soon we are going to have AI process in the company also. So that's how we have to conserve the seeds. And many times basically it is coordination between farmer and beekeeper. If the beekeeper is taking pollen in your orchard, then you should continue to control the bees. You should not go for the unwanted spray of pesticides. And if you really want to carry out this pesticide application, you need to talk to the beekeeper so that he can kill those colonies or he can close the entrance. And you can always go for the selective pesticides like granules, so that it doesn't affect the pollinators. And there is climate change, and if you use the cover crop, you can certainly minimize the damage which is being done to the pollinators. So here you can see in cabbage that in Indian orchid they use clover as a cover crop, and the many times the pollinator population increases. You can always go for the planting of crop which gives pollinator. Here you see additium, they go into the native plant. Additium is very good source of nature for the fish. At the same time, fish will do pollinator and it acts as a bioregulator of the native plant. Eucalyptus specially is used as a herbicide as well as it is very good source of pollen for the created mite. And created mite at the same time is used work as a bioregulation. So we need to have bee gardens. All the government institutes, maybe the national institutes or agencies, we need to have bee gardens in all the institutes. That is, because they give oxygen food to the pollinators and other things like nectar, pollen, gives them the light, it gives them a very for the oxygen. And there is work done how to carry to a lot further this part. And right from 1% to 15% we can allow. But if you have less than you can do for waste area for the setting of the tree garden. Otherwise, 15% was found to be very good. And you need to have so many annual plants, biennial plants, perennial plants, including this, which gives the very good quality for the nectar. We have already arrived at the plan which can use, then which can act as a source of food for the pollinators. So this is a picture of one of the big gardens which we have constructed in the area. So now this is one of the photos taken maybe about 5 years ago. So pollinators, big gardens in a different state now. So thank you very much. I extend my thanks to all the others for giving me the opportunity. And I thank the chair and coaches for taking here.
Very nice presentation. Really set of pollinators. So you mentioned that we need to lower the food is very important. And scientific and awareness, we need to stop it. Yeah,
I'm on. Thank you, sir.
So when I joined India, I was very educated on what the nicotine alarm.
for so there are a lot of things which are thoroughly developed. But the honeybees and bumblebee, not honeybees, pollinators, the bumblebees, they like to and they get addicted to nicotine, and that helps in the movement of pollen. So I want to ask, maybe finish, which better the race, because the bumblebees, when they take nicotine, they go rosiness and other things, that activates the neurotransmitter. So whether we can use this lighting of honeybees to nicotine, and because that enhances the memory power and also the food group behavior. So whether we can that thing we can use to get the honeybees to memorize the pesticide response to cover. So that they don't go to pesticide crop and they will not be disturbed. The honeybees are not getting high pesticide. So whether we can use the nicotine to teach bumblebees, and that we can expose bumblebees to nicotine from an intermediate. After that, we can release those crops.
So actually, I have discussed this issue earlier also, and unfortunately, our center area has not worked on the pollination issue. But first of all, I would like to study the effect of pollination in tobacco. And certainly, if that is the case, nicotine is being used to for memorize, and actually, government warned that we do not consume nicotine. But it certainly has the improve the memory of pollution. We will carry out this methodology, and we will come back to it. Thank you, madam.
So we get together, we get agriculture, and then you got the artificial intelligence, all these things are interesting, and the farmers are very interested to focus on this coming technology. So already we are experiencing the development and the opportunity in the legislation. The existing population and the population so the idea is one, so we have to create the future, exactly to the agriculture and the for the upgraded technologies in agriculture, whereby the information of the traditional and the modern agriculture. So that we improve the economic performance. So I request my person about this. You all had a good time. already mentioned. So what I want was we have to very quickly embrace ICT, information and communication technology, and see what best we can make out of it. And from academic side, I found one gap. Everyone is getting only NPT, National Program on Technology Enhanced Learning, where IIT faculty and industry people, software industry guys or our industry people will be collaborating to teach lessons for the students. Then in the technical session, I found the scientists will be very knowledgeable, very thoughtful insights, which they can also contribute to their organizations, collaborate with the industry people and academicians to offer lessons to the students, which will be of great help to the students, definitely. This is my concern. And the doctor's sessions have already mentioned. Thank you.
Great presentations by all the speakers regarding use of communications and also artificial intelligence. Another two important topics. So only thing is in a vast populated country like India, where farmers are illiterate, where shortage of labor is major constraint in the scenario of agriculture, where farmers are vast in number and mostly with small holdings. How best we utilize this artificial intelligence as a module is very, very important, rather than giving segment-wise modules. A total module that meets the needs of these three aspects is very, very essential, where the experts of artificial intelligence may think over and evaluate the module. That will be more useful for agricultural scenario. Thank you so much.
Thank you, madam. Thank you, sir. Now, as a token of respect, I request our chairperson to felicitate our respected speakers. First, I invite Professor P. Venkata Suresh, sir, Director, School of Computer and Information Sciences. I request chairperson to felicitate, sir. Next, I cordially invite Dr. Murali Krishnan, Professor, NIFTM. I request chairperson to felicitate Dr. Murali Krishna garu. Talks will start. I request madam to. Oh, yes, madam. Subhaya sir is coming. I request rapporteur Subhaya sir to please join. I request all the participants to please come forward so that it will be easy for the interaction. Please. I request Madam to conduct the session.
Providing the insights to all of the farmers through which they can improve their best practices in farm, which in turn improves the farm yield productivity and provides profitability to the farmers. As a whole, the farm digitization helps in as empowers the farmers and also helps as a source of sync of data through which is available to all the stakeholders under a single platform. Next, it also helps in providing the global certifications and also gain the business from the blue chip companies. Next, coming to the technologies that were involved in the farm digitization. We are all aware of Internet of the Things. It is nothing but a network of several interlinked devices through which we can exchange the data and share the data with no or zero human intervention. After that, the blockchain system. The blockchain system is such decentralized, we can have a clear-cut track of the data, starting from the seed to the sink, source to the sink. For example, in tobacco, it is from seed to the cigarette sale. We have a clear-cut, robust, transparent traceability system. And after that, the third one is the most important thing for the agriculture, that is data storage platforms. It is known as the backbone for the farm digitization, especially in terms of agriculture, because it helps to store our data. It secures and provides privacy to our farm level data. Apart from this, it adds value to the data when we share with our customers. And in these data storage platforms, each and every data point, what we collect will have a geotagging, GPS traceability. So we can trace back to the individual field as and when we require some kind of traceability. Next, coming to the information flow in the digital agriculture. Firstly, the collection of data. Whatever the raw data we are collecting, we can store it under a single platform. So all the stakeholders can make data or access data. We are in the web into summaries, reports in the form of PDFs or Excels, which helps us in taking decisions in a short span of time. On the we execute some between our target and what we have achieved. Next, coming to the role of digitization in ESG, means after the intervention of this digitization around the trade, for all the companies, the ESG scores has been significantly improved. The reasons are because the ELC helps us in the decentralization of the data. Means the ESG data, if we are collected from the multiple sources, that can be decentralized or centralized under the single repository, so that everyone can have the access. It has a single source of truth, and it helps to provide the data catalog. Improving our data presentation and analytical techniques, so that we can compile with all the standards. And apart from that, as a whole, this form digitization helps in collection, collation, analysis and retrieval of data. The retrieval of data is very important because it helps us to score high during the time of audit. Then the customer or a third party will get the work on the document on the paper is as fast as the practice on the ground, so that we can score good audits and also get more customer base and also attract the blue chip companies for business. From here, I would like to take you through how GPI is involved in the form digitization. The GPI set of we are in with the mobile application. From the data captured in the mobile application, it moves to the server. There we can access the data in the web, understanding the technical know-how involved in data capturing technology, so that the field technicians will practice three most famous methods in collecting the data. The first one is through visual observation. Some data points what we have configured in the application related to the STP can be answered by the field technician through his observation without the involvement of the farmer or farm worker or any other person. And the second thing is by interviewing the farmer. Some data points can be captured directly or indirectly from farmer by interviewing him. And the third is interviewing the farm workers who are involved in the farm level activities. By using these three methods, GPI staff used to collect the farmer and also the socio-economic standards of the farmer. Based on the risk rating levels, like if the farmer has more number of children, based on his economic status, we are taking up some initiatives under the people pillar, like after school program, school infrastructure development, awareness. In the similar way, to double the farmer's income.
Allotted time is over. Try to conclude, ma.
So we used to capture the living income data also, and apart from that, wash, water access, sanitation and hygiene, and NTRM and taint risk assessment for maintaining the integrity. All the crop actions are scheduled with the stipulated from seed sowing to crop destruction and marketing. All the activities are scheduled in a chronological way. Data has been captured. Along with this, we are involved in capturing of minimum wage, which is the focus area for the GPI. And we are happy to say GPI farmers, 99% of GPI farmers are meeting minimum wage standards of government. Other unscheduled activities involve the CPI application or CPI disposal, which do not have a stipulated timeline to take a particular activity. We are into the wood traceability, and we are encouraging the farmers to take up cultivation to source the wood for all the GP farmers. For the last year, under the study, is rated under the zero deforestation. Next, coming, these are the crop stage images which we can capture with the help of mobile application, starting from seed sowing till marketing. Next, this is the traceability, how we do from the packed lot to the seed tray. We access the packed shipping case number, move into the bale number of the bale number format and also to the seed lot. There we can for whether is
Respected dignitaries on the dais and off the dais and all the participants, good afternoon all. So first of all, thank you very much all.
Excuse me, may I know actually what your, the speakers they had to, because here not mentioned your designation or this one,
Yes, yes ma'am, I'm just.
This one also.
Yes ma'am, yes ma'am. So I am M. Rajababu, Associate Professor from Aditya Engineering College. So first of all, I thank you all for giving me this opportunity to present my paper here. Actually, my paper and my area is not related to agriculture, but whatever the techniques or methodologies I am using in my research can be used in agriculture research also. So I am presenting a paper titled a novel hybrid approach based on multi-feature fusion CNN for age invariant face recognition. So as you know, face recognition is a biometric technique, so which can be used for identifying a person, but it is very difficult to identify a person if there is some age difference between query image and the dataset image. Okay, so in the proposed technique, I am using So as you know, the deep learning has a great advancement in the present research, that is also in the face recognition. So I am using multi-feature fusion CNN for efficiently recognizing a person across the age progression. So here I am using a hybrid method where I am extracting the three types of features, mainly local binary pattern features and surf features and the high level features that can be extracted by the convolution neural network. So these are the main 4 steps in my research for performing age invariant face recognition. So the first step is pre-processing, the second step is feature recognition, so feature extraction, and the third step is feature fusion, and the third step is finally the face recognition. So first the pre-processing techniques are used. Mainly I used illumination normalization and noise removal for pre-processing the image, face image. After that the features are extracted. Mainly 3 types of features we extracted by using the 3 techniques LBP and surf technique, and even CNN convolutional neural network also can be used for extracting high level features. So in the next step all the 3 features are combined and feature fusion is performed, and finally the merged feature map is given to the fully connected layer, that is softmax, for final classification or recognizing the image. And this is the architecture of my proposed system. So first the pre-processing, and after that the 3 types of features are extracted, and a weighted feature fusion mechanism is used for fusing the 3 types of features. After that it can be given to the softmax layer in the CNN, and finally the faces can be recognized. And coming to the data sets used, here in our research we used the 2 popular aging data sets, which are Morph Album 2 and CACD. And these are the performance metrics. So final accuracy we measured by using the 4 types of performance metrics: precision, recall, accuracy, and F1 score. And these are the results. So we worked with the 2 data sets, and these are the results. The first table is describing the results on Morph Album 2. So we compared the result with the state-of-the-art methods on age invariant face recognition, and finally we got 98.55% accuracy with our proposed approach. And the same technique we applied on CACD dataset, and finally we achieved 99.85% accuracy. So with this I am concluding my presentation. So we used a hybrid method based on weighted multi-feature fusion CNN for efficient age invariant face recognition. So we worked on 2 data sets and we got the better results, and those results are comparatively good when comparing with the state-of-the-art methods on age invariant face recognition. And another observation we got in this research is, so the total time taken for extracting the features is even less when comparing with the other techniques. Thank you all. And if there are any questions from your side, welcome, sir.
Very new. Only I understood that with the age of the face will change, that recognition process related maybe.
Yes, madam. Yes, madam.
I could able to understand.
Actually, it may not be related to agriculture, madam, but the techniques can be used in agriculture research, like
matters everywhere.
Yes, madam.
Like
leaf disease detection and plant classification. For performing these tasks, these techniques can be used, madam.
Okay, thank you. The next speaker, Dr. H. Ravishankar.
Thank you all.
Okay. Respected dignitaries on the dais and of the dais. So myself, Dr. Ravishankar, working as a principal scientist in the discipline of computer applications and IT at ICAR-NIRCA. So now I am going to present the soil test crop response based fertilizer recommendation system for FCV tobacco yield targets in northern light soils of Andhra Pradesh. So from the morning, many speakers told that we are using the digital technologies like artificial intelligence and data mining techniques. So to which extent these technologies are reaching to the farmers? So we can say that PPT. Okay. Yeah. So one of the technology, so what we developed here is the online fertilizer recommendation system. So when we browse through the internet for the decision support systems or the soil fertility recommendation systems, so the n number of sites will be displayed. And if any software, if any recommendation system which will provide the results based on the target yields expected by the end user. So I think this is a first of its kind to develop, especially for the FCV tobacco. So what is the background of this software? And we can say that this is a multidisciplinary approach. And so the back end of the software is a soil scientist, that we can say that is a domain expert, and the computer scientist, myself. So as a group, we developed the software, and which is available live in the internet. So the main objective is to develop a knowledge-based decision support system to provide a site-specific balanced fertilizer recommendation for a yield target of FCV tobacco through STCR-based prescription equations. So when we want to execute the software, so the back end of the software is a STCR equations. We can call it as the soil test crop response based equations. So how this software will be executed? Then coming to the computer science side, so what is the technology? So as per the tobacco growing regions, so we can say that there are 5 regions. One is NLS, that is Northern Light Soil, and Southern Light Soils, and Southern Black Soils, Traditional Black Soils, and Karnataka Light Soils. So in each region we have n number of auction platforms, and again in each auction platform we have to record the n number of parameters. So when we store all these data into the software, and if we can select a particular region and a particular platform, then again it has the 2 modules. One is the farmer details and followed by the soil test data. So it is a comprehensive package, so which includes all these regions. So when we do this software as an information system, it will take time to execute it. So what is the technology behind it? So here we use one of the technology that is called the data mining techniques. So this is a current edge technology in the era of IT. So in data mining, so we can extract the what data we required from a huge amount of database. So one of the algorithms which we applied is the one of the technique we call it is a classification. So how we can classify and what data we require. So here whenever you can select for example SLS area, so the remaining regions will not be loaded into the software. So an algorithm what we implemented here is the decision tree. So the decision tree means out of 5 regions, if you can select one as SLS, so automatically the auction platforms in SLS will be loaded. So the remaining 4 platforms will not be loaded, which reduces the time and increases the execution speed of the software. So that is the 2 main parameters which we require when we want to develop any software. So this is the home page of the software. So here you can see on the top, so there is one module which is called the administrator. So in the administrator, the user can edit the STCR equations, and we can modify the equations, and which are, I told that, acting as a back end of the software. So these are the equations. So we can modify the equations. So automatically it can perform the computation. So once we can change in the administrator mode, so this will be automatically executed in the database. So this is a user module. So here the user module consists of only 2 modules. One is called the farmer details, followed by the soil test data. So there are some threshold values for each and every parameter which are already preloaded in the database. So once we can give these values to this database, so we can say that the report will be generated like this. So this is only a component of the entire software. It is a comprehensive software. I am just displaying only the software for the NLS, that is the Northern Light Soils. So you can see the report which will give the input what we are given, and similarly the nutrient recommendations and the fertilizer recommendations, and these fertilizer recommendations are based on the target yield expected by the end user. So for example, you can see in the last parameter, that is the yield target. So here in the yield target I was given as 25 quintals per hectare. So if I change it to 29, automatically the entire computation values are changed, and the recommendation will also be changed. So that's why we can say that this decision support system is entirely different, which will only based on the yield target given by the end user. So the practical utility is the farmers of a specific agroclimatic region can get the fertilizer recommendations for their fields by using the soil test values for a desired yield target of FCU tobacco. So this is a online system, and globally we can access from anywhere. So we already demonstrated this software in the tobacco board fields. So they are also tested, and which is working fine. So this is a user-friendly recommendation system, so which will assist the FCB tobacco farmers in getting an efficient and balanced fertilizer recommendation for specified yield target, and also helps in sustainable FCB tobacco production by maintaining the soil fertility. So then coming to the scope of expansion, why? Because each farmer may not have the laptops or the systems. Now the next version of the software is we are planning to develop a mobile app in local language, especially in Telugu. So within a one shot, that means within only one single screen, the user will get the recommendations in Telugu as well as in English. So the software also obtained the copyright from Government of India. So thank you for your kind attention. Thank you.
Very useful to the farmers for tobacco cultivation. So my request is the same type of work may be developed for other now commercial agriculture crops which we are discussing since the last 2 days.
Yeah, okay. Okay. Thank you.
Useful. Okay, thank you. The next speaker, Sri Sridhar Reddy K from ITC.
A pleasant evening to one and all. For next few minutes, I will take you through role of humidifier in artificial conditioning in FCV tobacco. In FCV tobacco post-harvesting operations, it majorly includes curing, conditioning, bulking and grading process. After curing, the tobacco leaf is dry and high brittle in nature due to loss of moisture, and it is not suitable for handling operations. So, farmers will place on a separate racks called conditioning racks where leaf is allowed to gain moisture from the outside atmosphere. This process is called leaf conditioning and it is a natural process. And depending on outside environmental conditions, it takes few hours to few days. And coming to what are the major challenges in leaf conditioning. Nowadays, due to climate change phenomena, weather remain highly unsupportive. And generally, leaf conditioning occurs in the early wee hours, that is in the early morning hours. This is a challenging time for labor to engage, for farmer to engage the laborers. Even if he is able to engage the labor, they demand more and their productivity level for the next working day will obviously come down. Additionally, a majority of the farmers will possess a max 2 conditioning racks, and any delay in conditioning will mount pressure on the harvesting process. This harvesting process in tobacco, which is cyclic in nature and impacting the quality of tobacco. Yes. To overcome all these challenges and as a future readiness, ITC Agri Digital Cell designed and developed humidifiers in 2019 season. Later, we did some inbound trials. Here, the humidifier is placed inside a barn, and without ducting system, we allowed the mist to flow against the gravity. And in next season, we used ducting system. Because of continuous heat inflow from adjoining walls, this conditioning got delayed, and it took more time than anticipated. So, we fixed these humidifiers for conditioning racks. Generally, this humidifier is placed outside a conditioning rack, and by using ducting system, mist is allowed to pass on to conditioning racks where leaf will gain the optimum moisture level. See, this humidifier's working principle is it atomizes water molecule into mist particles by using mist makers or nebulizers. Each machine contains 6 to 7 mist makers, and it has sensor mechanism. Leaf after attaining optimum moisture level, the sensors will automatically turn off the machine, maintaining standard moisture levels so that over conditioning or under conditioning can be avoided. And trials conducted at farmer premise to gain his confidence revealed that the average time taken for one conditioning is 4 to 4.5 hours. Again, it depends on outside environmental conditions. And water requirement per each curing is 1 to 150 liters. As we are converting natural process to artificial, we need to check the quality of tobacco. So we bought around 15 tons of tobacco and we checked physical parameters at various levels like storage, packing, after packing. but there was no impact on the quality of tobacco, and it is in line with the naturally conditioned tobacco. So, deployment of these humidifiers help in solving certain challenges thrown by the weather and also labor paucity. And it also facilitates farmers to do as per their convenient time, either in the evening or in the morning hours. And it also helps in planning regular harvestings, even under low humidity conditions. And coming to financial metrics, to date, ITC deployed 30 number of humidifiers in NLS region at 100% financial assistance. And current year, we are planning to deploy additional 50 units with 50% financial assistance. The cost of the machine alone is 1 lakh per unit, and it offers a saving of rupees 2000 per each curing in terms of labor, in right time of harvesting and quality metrics. Coming to cost economics, the humidifier machine cost 1 lakh per each unit, and its accessories cost 27,000, including ducting system and silpolins. And per curing, it saves 2,000 rupees. With running with 50% capacity, it saves 10,000 per each bond. And these humidifiers are most likely suitable for a farmer who is having 4 to 5 bonds. If he operates at full capacity, like a 6 bond capacity, he can save 60,000 per each season. And his payback period will be within 2 years. I thank the organizers for giving me this opportunity. Thank you.
So I went back to my degree level of that memories after this one, your curing process and everything. Yeah, with this one we completed this plating tanks. Any questions or queries from audience? Yeah, related to these topics.
Sir, the question related to which speaker, it just fell out, sir.
Sridhar.
The humidifiers that you have used to maintain the moisture will be this one.
Yes, sir.
What is the optimum moisture that you would like to maintain, and where the humidifiers will automatically leave this one?
So the optimum moisture we are maintaining in the leaf was 18%.
18?
18% by using these humidifiers.
No, when the leaf comes out of the ball.
Okay, sir.
What will be the temperature moisture?
It will be less than 5.
So that will be less than 5. So immediately after that one, the humidifiers will start?
No, sir. We will place in the conditioning rack. We will allow it to cool. After that, we will switch on the conditioning machine.
Okay, you will place it in the racks. Okay. So when the humidifiers will start?
After 1 or 2 hours, sir. After
So
the unloading.
is there any mechanism that it will automatically trigger when the leaf moisture is this one?
Yes, it has sensor enabled mechanism is there. Based on the algorithm, whenever leaf come to certain moisture conditions, it will automatically switch off.
Okay, what is that moisture when it starts and when it stops?
Sir, the sensor has certain mechanism, that algorithm is there. When humidity reaches 85 to 90%, it will automatically switch off. 85 to 90% in the sensor, in the room.
Okay, so when the humidity in the room is 80 to 85%.
85 to 90%.
Okay, 85 to 90%. And what will be the leaf moisture at that point of time?
So at that point of time, leaf has 18% moisture levels. That was
18%, but what is in the normal condition when we say that this particular leaf is conditioned, and what will be the moisture content in the leaf?
So it will be around 14 to 16, not more than that.
But in our case, can't it be more? It is 18%, no?
No, sir. It will support immediate bulking activity. At 14 to 16% in normal conditioning.
18% is on higher side.
14, 16,
18%, that what you are telling is, and 18% moisture in the leaf.
So in bale itself we are getting 12% moisture.
Bale will be after after so many this
yes,
one, no.
after grading,
packing,
bulking, packing, it is having it.
That is different. So
by that time I am switching off the machine, humidity will be 18%, sir. And when it comes to bulking, again it will subject to some drying. Again there also moisture will loss.
Can kindly see, because that 18% moisture, it may invite the molds also.
We tested, sir. There is no soft stem. Soft
in a leaf, 18% moisture.
Sure.
Are you convinced? I am not much aware of this one curing that what is the percentage? So are you satisfied? Yeah, please let me know, sir, because.
No, I'm satisfied. I'm satisfied with the answer what
Any more queries? The first speaker, Prashanthi, with the digital technology in tobacco. Anything? Any questions? If not so.
Your name is Prashanthi. Very nice presentation. Slides are very nice. Can you throw some light on the challenges, because you have just mentioned the whole thing, overall process. So many challenges are there. Can you just mention one or two challenges with that digitization, form digitization?
The challenges in the digitization is lack of knowledge to the farmers. We have to train the farmers multiple times and making them aware of the digitization. The understanding levels of farmers sometimes might not be up to the reach of the digitization. That is the major problem, that hiding the farmers is the major problem, challenge we are facing. No ma'am, I was not aware of the technical details. I was just involved in configuring the things, and also the question is related to STP. We just aware of the challenges in training and collecting the data or the errors we get. I was aware of to that extent only, not into the software. Thank you ma'am.
Okay, my congratulations to all and presenters who did their beautiful presentations. That is actually come over here on the stage and talking itself is an achievement for them, for young scientists. And with this one, we are concluding this session. So any remarks? Okay, thank my co-chairpersons and rapporteurs of this session.
Okay, on behalf of everyone, I thank chairperson, co-chairperson and rapporteur for successful conduct of this oral lighting talks, presentations. Okay, thank you madam, thank you sir. Let us break for 10-15 minutes. After that panel discussion, 4:15 we'll start panel discussion on ashwagandha, castor and mechanization. So combined panel discussion will be there. So the delegates from hall 2 yet to come. So after that we'll start. Thank you. Madam, please come. And I request rapporteur Dr. P. Manival sir, Principal Scientist CTRI, to please come and occupy the seat on the dais. I request Dr. Anandita to give floral welcome to Chairman.
Yeah, friends, we are coming to the close of this international conference. Yeah, please. So friends, as I said, we are coming close to the conference closure, but at the closure, it's not the last. It's the last item, but it's not the least item, which is very important panel discussions. Our friends are witnessed yesterday, last 2 days, witnessed the very good, very vibrant panel discussions we did yesterday, day for yesterday on tobacco. Yesterday we did on chili and turmeric, which Neeraj Prabhakar Madam, VC Madam could have been there, but somehow Madam was not there. Today, Director IAOR, Indian Institute of Oil State Research, Dr. Madhurji is here, and also VC of Kondalakshmaya, Telangana State Horticulture University is here. We just know we exchanged MOU. Really this MOU will foster the relationship between the two organizations, Madam. We were trying to have a MOU from long time, of course, but somehow it not materialized, but it's materialized on a right day. I mean, I feel this is a, because our scientists even came from regional stations also. One of the regional station is there in Mysuru, in Karnataka, I mean that is in Hunsur, near Mysore. As you said, their productivity levels are very high, and that region is very fit for turmeric. Already they have taken up trials and they are doing, and now we are part of even Acrip of spices. We are a partner with Acrip in oil seeds. We are a partner in Acrip vegetables for chili. Even we are partner in Acrip of medicinal plants. So apart from tobacco, we are now in 4 Acrips are there. Altogether 5 Acrips. We are a center. Honorable DG says that you should be there in every crop so that you know, understand the technologies what they are developing as a leading institute, which you can replicate at your area for value addition. So that is a clear message he has sent. So that's one we are following. So coming to the topic to I mean for now maybe we will conclude as you have a other assignment how, I mean what are the potential aspects or what are the gaps in ashwagandha and castor in a commercial agriculture. Please go ahead, madam, first. Yeah, you can.
So now this is today's in this session we are going to discuss about castor and ashwagandha. So in the morning, as I said, this ashwagandha scientific name is Withania somnifera, which belongs to the family Solanaceae only. And so because of the Sanskrit word that means horse smell, it gives the smell of horse sweaty smell. That is the reason this name came. So most of the people are not aware of the uses of the ashwagandha, which is having medicinal values, and they will see the uses like helps to fight the depression. So that is the reason actually, during the COVID, so most of the, apart from this turmeric, this is also came into the picture. And you know that nowadays, so most of the even young people and everyone with much more stress, pressure, so going into the depression. So that is actually, our age-old practice of using naturally available spices in our kitchen, which that improves our immunity and make us healthy. So even the combined family system also somewhat, so contributing to the healthy atmosphere among our kith and kin. So then increases the muscle mass, that is the one thing, and it helps to reduce the stress and anxiety also, and it enhances the memory and controls diabetes. You see all the benefits, this one, and it safeguards your immunity, improves the stamina and reduces the weakness, and it is the best herbal solution for overcoming the infertility in men and women, and control excess weight gain and reduces the inflammation. We thought of habit of taking this ashwagandha powder, just mixing 1 spoon of chapati flour duff in preparation every day. So it won't change your taste of the chapati and it easily consumed. That is one method. The other method is like mixing with the milk. So like Horlicks, Boost, one spoon mixing with the milk and drinking, that also it helps us to improve our immunity, especially nervous system weakness will be overcome. So nowadays it is because of intake of this all junk food, so youth and in people, not only that, and ourselves, middle-aged people, everyone is facing this problem. So you can overcome somewhat by intaking of this. So here it contains that alkaloid vithamine, somniferin content of 0.13 to 0.68, and gives an yield of 600 to 700 kg of dried roots per hectare. So what are the yield attributing characters that we can see is that is the number of secondary roots, fiber content, fresh root yield, dry root yield, root length, and alkaloid content. I think in Orissa, OUAT having the maximum number of collections of ashwagandha. So you can contact Honorable VC of Orissa, and we have some that, but not like, I'm openly I'm telling, not that much, very vast germplasm. OUAT is having that much germplasm, but we are cultivating even our MSc students, they conducted research on that one. So we will share that information with you. And if we'll see the marketing opportunities, one thing that is the Neemuch and Mandasar markets of Madhya Pradesh, which are popular world over for ashwagandha, and importers, buyers within the country, processors, traditional practitioners, Ayurvedic, Siddha, drug manufacturers, all these, they will procure ashwagandha roots every year, and the domestic demand for ashwagandha roots, as stated earlier, it is about 7,000 tons annually. So now at present that production is less, only 1,500 tons in India, and the internal market itself is highly potential. So the sale price of dried roots is roughly around 150 to 200 kg, and seed is required for propagation. So that is, there is for that also there is a demand. So that is about like 150 rupees per kg. Okay, this is about the basic information. From this is information I got from the National Medicinal Plants Board, New Delhi only. Okay.
Thank you, madam. Yeah, we are looking for the opportunities from the state of Telangana and Andhra for the ashwagandha. How much is there? I mean, how much area is already occupied? Or is there any, we need to do something, area improvement can be done?
Actually, it is not required so much irrigation, even unused lands. In the morning I told, like infertile lands also, we can use for the cultivation, and even this can be grown as an intercrop also. Yeah. So unexploited areas with low irrigation facility, even low fertile soils also can be used for the cultivation.
So you say that there is a lot of scope in unexploited areas, so there is, the area can be increased in Telangana and Andhra where we are there. Okay.
Can be cultivated and rain-fed. That is also one of the
maybe we need to identify the best varieties or best germplasm, best lines suited to this zone, maybe. Yes, we can put in a student or somebody, we can work together now.
Yes, that is
start
required.
doing that. Okay. Yes. Okay. So, madam, but I came to know that some areas adjoining Hyderabad, people are growing and they are taking those routes to Neemuch, Madhya Pradesh. Yeah. So, and they say that it is very good. It is even not, even cattle also doesn't eat that leaves and all. So they say it is very good. So in that case, if that is there, maybe we will put, our economists are there, we will even put the marketing studies and potential of ashwagandha, and because CMAP, Bodupal, also working, but they are not working on area development. I think together we can do in this ashwagandha journey, to make it more better. Okay, madam? Is it?
Yes, and one of the private organization also, they are working there, that person meet us and asked for about the seed production they required. We asked them to give the intent, how much that is required, so that with like MOU understanding, we will go for that cultivation of ashwagandha, we'll provide seed.
You have any
But not
FPO?
yet materialized right now, but we
Oh.
asked it. So
You have any FPO, madam, on doing for ashwagandha's production? Any
no,
FPO?
no, right now, no, we don't have any FPO, and after, so the suggestions that are coming from this panel, we will take into consideration, and I'll discuss with the university officer, especially director of research and the head of our medicinal and aromatic wing is there. So with that one, we will take forward, and actually, we thought of collecting different kinds of, not only the ashwagandha, different herbals that are available most in district of Adilabad, as well as near in the Peddapalli, Ramagiri Killa. That area is famous for medicinal herbs also. So we thought of exploring that one, and that I was assigned to concerned scientist. It is due.
Okay. Yeah, for your information, madam, we have brought, we are bringing almost now packed in NPB gel, lot of germplasm, and also we have one expert with us. I forgot to introduce. He is Dr. Manivelu, who here, madam, he is a rapporteur. He is earlier director for DMIPR, Director of Medicinal and Aromatic Plants at Anand. So his expertise is there here, and we have one more breeder who can do completely an ashwagandha. So, and also we are bringing a lot of germplasm. Maybe once we multiply, we can even give to you to see the suitability regions, what you said, different Ramgiri and other places, so that we can proceed together. Okay? Thank you, madam. Yeah.
Happy to meet Dr.
Yeah, he has a lot of
Manivelu. So
expertise
he
in that.
introduced himself, that is as a
Yeah.
specialist in ashwagandha. Definitely we will utilize his expertise for this improvement of this crop, especially ashwagandha.
And also we have a MOU with ICT, Indian Institute of Chemical Technology, for isolation of all compounds. That work is already started. He also there. He was there for last 2 days. Unfortunately, gone yesterday evening. So he is characterizing all the compounds. What you said, like vithanolide, vithaferin B, and all. So once we know which one is good, one X type is good, one B type is good, I think that will be the good information for you, so that we can go ahead.
I request you throw light on actually how better uses that can be in case of this, especially ashwagandha right now. Any scientific information that is approved, if anything, please highlight those things in this.
In short, madam, ashwagandha after COVID has become jump of requirement. So the last year it was 826 million business has been taken care, and another 2 years it is going to 1,200 millions. So but few things only. Number one, the demand and supply, as our director was telling, that who is purchasing, how much they want, this information is hidden. The same ashwagandha is exported in different HSN codes. Yeah, different HSN codes. So as a result, it is going as a tablet, it is going as a powder, it is also going as a nutraceutical, it is also going as a functional food. So different farms it is going from India, and different companies are going. So there are more than 1,200 companies are exporting, sir. In that 20 are major players. Yeah. Yes, there are so many farmers producing organizations now coming as a cluster. The Neemach is also present situation after COVID is the farmers are now well known about that international market, how it is going. So that is why last year in Neemach every farmer who was going on bike is now going on I-20 cars, even Tata big cars they are purchasing. The yield profit was enormously high.
One thing has to be addressed is marketing. So the assured buyback that is has to be created for the benefit of the farmers. That's one thing.
Actually, Dr. Manivel forgot to mention, he is working in our own regional station located at Vedasanduru in Tamil Nadu, where he is working together with NPMB,
National Medicinal Plant Board, NMPB.
where he is developing GAPs and developing farmers to use that one, and he already conducted training for them, and I mean, he has an extension program where he wants to
manage Hyderabad.
how many districts? One district.
So total India, sir.
Yeah. So there, I think now when we signed MOU with Telangana, you can do there also.
Definitely.
You can survey, and then that will help for both.
Definitely, sir. Already our Vallabhasavanda varieties in Telangana, madam.
Yeah, that is not clear whether Vallabhashvagandha is there or something else is there or some other maps varieties are there. They're not clear actually.
Yeah, that's
so
sure.
that we need to make it very clearly. Unlike other crops, it is not clear. Yeah, sound is a little bit is there, sir. Yeah, echo is there. Yeah, with this only we could manage. Yeah. Yeah, yeah. So. Yeah. So, shall we shift to castor now, madam? Because we have an expert in oils, complete oils. He is expert. One side oil palm, other side oils. So we can hear from him. Okay, sir.
गुड इवनिंग एवरीबॉडी। आप मुझे कैस्टर का एक्सपर्ट तो नहीं कह सकते कि पिछले 1 साल में मैंने ज्वाइन किया है वहाँ पे ऑयल सीड्स में। इससे पहले ऑयल पाम में मैं ज़रूर था या ग्राउंडनट में था, और मुझे जैसा बताया है कि आपको कैस्टर के पैनलिस्ट के रूप में काम करना है। सो let me do justice with that. Respected Director of CTRA, Sheshu Madhav Garu, Madam Vice Chancellor Garu, my colleague groundnut breeder Manivel, my seniors sitting here, Dr. Murthy Garu, and dignitaries of the dais, ladies and gentlemen, it's my pleasure to put before you the views on castor. Of course, some gap analysis has been done, and now it is your mandate crop also. So let's try to see that we don't duplicate the work, and where our weakness is there, our limitations are there. You have strong laboratory and equipments and manpower. We can club third person also, maybe IICT or something. And then we can work together on the post-harvest or value-added products aspects. So panel discussion is on castor, and then mechanization is separate. Anyhow, mechanization we cannot deal in isolation. Mechanization in every crop is very, very important. And looking at the quality of the manpower available, quantity of the manpower, physical manpower available, these things are becoming very important, where we are moving towards the varietal development or genotype development of technology development, which can help replacing or at least substantiating the physical labor. So as you know, castor crop, we are dealing with 6 crops. Indian Institute of Oilseeds Research, we are dealing with 6 crops: sunflower, safflower, sesame. These 3 you know are very well, highly edible, best quality oil, and very superior oil, cooking oil, all those things. Another thing is that Niger and linseed, these 2 more crops are there, which are again having industrial uses, and then castor, of course. So other day also, Madhav Garu, we were discussing that why edible oil it is getting disappeared around 18 to 20%. Some scientific studies there. Water oil import or production is there. It is disappearing in the sense somewhere else it is going, and definitely industrial uses are there. So we cannot say that that is wrong, but at the same time we can try to see that requirement for industrial uses are also met. If that is done, then probably edible use can be saved for the edible purpose. So that sort of discussion we have been having, and their castor become very, very important. And then again, other day I was discussing with Dr. Manglara how much weightage this institute should give to castor crop, which is non-edible, and our national requirement is edible oil. So probably we could not have good conclusion. But thing is, castor brings a lot of money to farmer. It is export-oriented crop also. So I will just try to push forward. 2-3 decisions we have taken very recently. Whatever we do, the quality seed is very, very important. And that also, while you are talking of the ABR system of hybrid seed production, this becomes further important. The quality of A line, genetic or purity of A line, R line, which is the restorer line, and how it is crossed. And if it is crossed, again it is a monoecious crop, where temperature or stress again change its expression, sex expression. So it is really challenging crop, and quality seed availability to the farmer is very, very important. And the first while I joined in previous November 22, I have gone to farmers field, I have gone to my colleagues where they were doing all those sort of things and discussing. And then I have seen that lot of hardship they are having. Farmers were involved in seed production under technical guidance of IOR. And looking at all these things, we thought that let's, and then how much area we are going to cover is just 18 or 20,000 maximum hectares, which is not sufficient. And especially for ICR institutes, where our varieties generally don't find a place also in package of practices in state universities. So there this thing become very important, and first decision we took is that we'll license the hybrid. This decision was not easy first time we were doing. We discussed here and there, and then we could go through Agri-Innovate at a national level, which is ICR body. And then we have licensed this hybrid, and one FPO in Anantapur, which is related, which is doing seed production activity, we have licensed. So that first activity we did, and that needs to be replicated in many crops, so that we can reach out to many farmers, many stakeholders or more area. Second thing is, I was there in Anantapur other day, and there it is traditionally groundnut belt. While I was there in Junagadh, Gujarat, that time we used to listen that Anantapur, it is a groundnut bowl, lot of groundnut areas there, this and that. But now slowly it is reducing due to some or other reasons, maybe there. But while I was there as a director of the institute, then we have seen that groundnut they are replacing with the castor. Then we discussed with the farmers, we discussed with the entrepreneur there, and we observed that first is the problem of rains. Definitely in groundnut we lose the flower flush which would have come early, medium or late time. And if during that time moisture stress is there, farmer is not getting anything. But other than that, what were discussed are the wild boar problem and those things. And their castor, 5,000 acre area I roamed around, they have converted, gone to the castor. I will tell you that these pulses, millets and oil seeds, they are mainly highly climate resilient crops. Castor is one among them. So again we were deliberating with many higher-ups and this. So castor primary spike is coming, and then if primary spike you lose due to some more stress or something happens, at least again secondary, tertiary spikes are there. And that how, even if some late rains or some moisture available, a farmer will be able to harvest. So that is the beauty of this castor, that what we thought. and our people also started working. Third point is that to fit in a cropping system, we have to breed varieties accordingly. So if it is early hybrid we are developing, we are targeting 100 days, then farmer can harvest maybe primary one spike or maybe 2 or 3 more spikes also. But he can go for the close planting and it becomes as non-branching type, and there he can harvest more. That is one idea, one approach where we are bidding for the earliness. But at the same time, second is that at a time, if more spikes are coming up and within a short window of 15 to 20 days they are maturing, so that also is desirable trait in some other area. You cannot say it is all generalized. You have to identify which area require what. And thanks to our colleagues there, led by Dr. Lavanya, who is heading this castor research group, we have come out with similar type of material also. And recently our RSC and all these have visited, they were so happy. Third is that harvesting is a problem. What we are giving farmer is a cicatear. He will cut that primary spike and take. Again, it is a work which requires labor and treasury. So if mechanical harvesting is possible, that can help farmer in harvesting properly. So that aspect also we are keeping, where instead of more branching or no branching, if it is single culp or single spike, then it can also add to the harvesting easily, where you require some uniformity in the harvested produce. So on that aspect, our material is available now. But more so is involving these FPOs. These FPOs in seed production, FPOs in cultivation of one or other crop, maybe castor also, which will help in promoting the crop also, bringing more area also. At the same time, resources can be shared so that cost of cultivation can be reduced. All input and resources they can share basis. Marketing can easily be done since it is through the like-minded group of the people there. And in that way, that any crop can be promoted. Here I will share with you one more experience. Safflower. While just we were there in field, and on that time only we purchased drones during March, and we were asked to conduct demonstrations. So our colleagues, thanks to Dr. Suresh, who is heading that, and then we have gone there. I was also watching, farmer was also there, and through drones, spraying was done. Spraying is generally done, we are seeing. मैरिज में भी काम आता है, कोई एक्टिविटी को जो कवर करने के लिए भी ड्रोन का यूज़ होता है, लेकिन स्प्रेइंग के लिए भी हम लोग जानते हैं. बट दैट वाज अप्लाइड टू सैफ्लॉवर कल्टीवेशन. सैफ्लॉवर यू नो कांटे वाली क्रॉप है, वाइल्ड टाइप, एंड देयर इफ यू आर आस्किंग समबडी टू स्प्रे, फर्स्ट थिंग इजीली नोबडी विल कम. इफ ही कम ही विल चार्ज मोर, क्योंकि कांटे वाटे लग के उसको थोड़ा फिजिकल डैमेज भी होता है. विद ड्रोन 450 rupees per acre. That was the mechanization aspect. Farmer, I have seen farmer's face. He was so happy. His problem is solved. So just a small intervention, elsewhere it is done. And just we applied there and problem is solved. Then comes harvesting. Harvesting is almost very difficult. क्योंकि वो काटेगा तो उसका हाथ छिलाएगा, जो भी होता है. ग्लोव्स से हार्वेस्टिंग मुश्किल होता है. So then these simple harvesters are there in market. उस हार्वेस्टर से जो हार्वेस्टिंग करवा दिया, नो सीड लॉस और बैग तैयार होके आ गया. सो दैट हाउ दिस मैकेनाइजेशन एस्पेक्ट आल्सो बिकम वेरी इंपॉर्टेंट, एंड दीज थिंग्स व्हाई आई एम टेलिंग ऑन सैफ्लॉवर वी कैन इजीली अप्लाई ऑन अदर क्रॉप. ऑफ कोर्स कैस्टर आई एम ट्राइंग, आई हैव सीन वन हार्वेस्टर आल्सो, बट स्टिल लॉट ऑफ थिंग्स हैव टू बी डन. रीडिजाइनिंग कैस्टर प्लांट टाइप. व्हाट कैस्टर प्लांट टाइप वी सी इज primary, secondary, tertiary, like that. So that plant type needs to be developed for the high density planting, which can help you in mechanical harvesting. And then synchronization. Synchronization you can think where almost control conditions are there. क्योंकि एक साथ फ्लावरिंग आएगा, एक साथ मेच्योरिटी आएगा, उस पीरियड का स्ट्रेस फार्मर विल बैडली सफर. So wherever it is sure about the management conditions, their synchronized variety can be promoted. At the same time, this crop is highly drought tolerant and this. If we want to really have, want to work with the CTRA now, I don't know when your name is going to change, but still it is CTRA, but talking of castor, ashwagandha and many things. So there are many products. These products are again how they are produced, how they are isolated, that is not much available in public domain. And what we are selling is the seed, it is going, or oil, it is going, there they are developing something and we are getting the commercial product for our use. There we have to intervene, there we require your support. I know your laboratory, while Dr. Murthy sir was there, I visited that, and very good equipments are there. So there we can really work together. What are the oleochemicals available? What are the different forms of, especially now very recently, we are going to get, not got, gene editing project also on castor, where this resin content that we want to modify. And if you see the castor oil derivatives, there are many types are there. I don't know, grade 1, grade 2, grade 3, many types are there. Those derivatives, we can take help of ICT and you also, and we can come out with what are the derivatives, what characterization is there, how to isolate, and those sort of things we can really take up together and come out with the products, and these products can easily be marketed. So what European countries and they are doing, we also can do that. But probably what I heard, I don't know, I heard is that lot of investments are required. So those investments will come next. Before that we should have technology available with us. So if that we are able to do, not only this institute and this, but that benefit can be given to farmers. Another last thing is that value addition also should be part of cultivation practices now. Cultivation practices in the sense seed to the crop raised by the farmer, and then produce harvested, and from produce also some sort of intermediary steps can be taken by group of farmers or something to reduce the burden, to reduce the volume which they have to carry forward for next step of purification or identification or derivative development, whatever is there. Small scale it can easily be done. Why I am telling you, that margin also can come to the farmers group. If it is in FPO, then FPO can some scale have some sort of expellers or some sort of industrial development, some equipment which can be supported through custom wiring center or something like that. So that profit margin also can come to the farmers group, and that can add the profitability of the FPO. At present I am blank what can be done, but definitely it is easy. Other day, just 2 days back, I was there in our oil palm conference, and there all entrepreneurs have come and I was discussing with them. In Northeast, Mizoram, we have promoted oil palm, but certain oil palm areas, they are not accessible, high terrain area, and if bunches they are transporting to other, then it adds to cost and it is very difficult. I myself has gone there, different terrain, difficult terrains. I traveled also, rather I was vomiting. But still we have gone to the last point and then see the plight of farmers and all. And then I was telling our entrepreneur friends there, why don't you reduce the bunches which you are carrying in trucks to other places, that is the processing unit point. Instead of that, you reduce this burden there in the small area there itself, so that fruits only you are carrying to the processing unit. So in that way you can reduce the volume which you are carrying, where it is very difficult terrain also, and some small development, not big also. Separation of fruits can be done and fruits can be taken. So that's what now they also told we can work on those, that sort of aspects. Another thing what we are promoting now in oilseeds is that if it is farmers group, some 15, 20, 25, 50, 100, if more 500 FPO, whatever is there. But crops should be, not only crop, particular variety also can be promoted through them. And then we are providing the extraction unit. That extraction unit is there in the KVK or our research center like that. one place. Farmer can easily come, he can extract the oil, bottle it, take it for own use. Maybe they can give to nearby our their family members or nearby supermarkets. So in that way, these things become very, very important, especially in Andaman Nicobar type area, this northeast type area where small pockets, they can become self-sufficient. They can produce, they can extract it, and oil can be used. And where cost also is more while they are importing. So these all small experiences I have, not much idea I was having. And I can definitely submitted paper also on this, and we can further send you that what are those derivatives, what are the products which can be developed, and that can be included in your proceeding and later in our research programs. So with this I conclude. Thank you very much. I was thinking that some more factory people and they will be there, so I will be getting benefit out of that. But anyhow, on 7th February we are organizing one industry meet at Hyderabad. So we will be inviting those people also, that what are the expectations of these processors or industries from us. One such aspect we got it is that sesamum. Sesamum, they want bold seeded sesamum variety for export purpose. Now, if you have, other day I was telling them in Jaipur, some meeting was there, they invited also export council. And there I told that these things can be taken care if you are starting right from the seed to the exporter. Exporter cannot work in isolation. Let him collaborate with the any crop producing organization, something. And this crop producer, they can associate with the institute like us. So right from the seed to that economic product, it will be uniform on the desired line, and they will be getting the material also of single seed. Otherwise, if they are taking from the market, it is mixed lot, and many times they are in disadvantageous position on export front. So that model can be there in many crops and these oil seeds also. Thank you very much. Jai Hind.
Thank you, sir. Thank you, sir. I think you covered complete from the beginning of seed to post-harvest technology you covered, and I have taken some of the notings. Yeah, among all, as you said, that important is, which I was also telling to you that we were discussing with ICT, the technology what they had is not foolproof, and it is very costly. The protocol of extraction of compounds from castor oil, again they are revising, because the one which they developed has many effluents in that. So that is the reason industry is not coming up. So that is the reason we given, when I did a MOU, I have written first point is this only. So, but still they are not worked on that, because why they also wanted some kind of a funding. So maybe with IAR and NIRCA and ICT, we can approach DBT or DST for perhaps, or Minister of Environment, somebody will approach, and then we'll go ahead and but my scientists already started a project with ICT in the Institute more, and then we are this corpus fund, we are in the corpus fund we are trying to do some of the things. Before we get some funding, big funding, we want to do some kind of a prototype, protocol development. Then we want to go for a bigger project, upscale. Then we can approach the company like Jayant Oil Seeds or somebody. I even tried for Solvent Extraction Association President Agarwal. He said same thing, that we don't have that protocol, so isliye humne, that's the reason they are sending out the castor oil and importing a castor oil derivatives. Like we are exporting to the 4,000 or 6,000, but bringing back by around 10,000 crores. That's what he said to me. And I also got a report from your institute, which brainstorming session done by the chairman of Dr. Mahapatra. So those things are there, but the other point which I want to do is that, which I just now I got, that expellers can be kept. My KVK head is here, Dr. Prasad Babu, who is in Kandukur region, which is also a dry region. Their caste is also coming up. So there we can put a expeller. Whoever are growing, as Dr. Madhu said, we can do in a custom hiring and we can promote the area and we can do some of the things. So that we will do, sir. Other things like synchronous flowering and all may not be possible at our institute. Yeah, you can take care of those things. I mean, changing the plant type and all, because we are not doing a breeding part. Maybe this we will try for harvesting machine. We will try that harvesting machine. Yeah. Grey mold. Yeah, grey mold is a problem, but it's now not much. I mean, bigger now area is coming down. What he said is area is coming down. Maybe it will pick up again once industry comes. So it was a problem earlier when in Mahbubnagar and other districts, but not now much. Okay, so I think I got a points for Ashwagandha, and I'll make some note on this, and then I'll send to you. And being a partner in ECRIP also, we'll get some material which is suitable for at least in Kandukuru and some other dry areas. We will try in that. And as I said to Madam that we are having a 2 KVKs. One is at just 10 kilometers away, Kalvacharla, and one is at Kandukuru, which is near to Ongol. So we are, apart from 6 regional stations, we have these 2 KVKs also, where the technology can be scale up, as technology can be given in a small scale farmers or maybe self-help groups. And we have 2 FPOs also. That also we are. So we are, I mean, we are a little bit stronger in, we have everything, but now the joining hands with people like IOR and with PGSTU and of course with IASR, I think the new name of NIRCA may flourish like CTRA, what it is done in last 75 years. That is a hope is there. Anything you want to add before closing? You can add. Seed production, yeah, what he was telling. Maybe we will do in a KVK. Sir, KVK के अंदर कर देंगे. Seed production यहाँ भी है.
Actually, he is talking about female seed production. That is female seed production. It's a pistillate mechanism.
Okay, if you can do, we'll do. Okay.
No problems.
Yeah, tell something.
Thank you, and I have noted all the points. We have came up with at least 4 or 5 action points which we can combinedly work with IOPA, our oilseed research, as well as with the Telangana State Horticulture University. Thanks for organizers to give me a chance to be the part of this program. Thank you.
Previous to that one, I want to add related to already I told during the epidemic period of COVID-19. So the market for this global market for ashwagandha extracts, value added products, during 2021 it was increased to $864 million, and now the projected to reach by $2.5 billion by 2031 with the CAGR of 11.4%. Because of this COVID only, the awareness about the health and immunity that is came into the limelight. So even European countries, especially North American countries, they started using this ashwagandha powder added produce in different for improving the strength, immunity, even as a sports drink also. And with this, so how this can be used is in the form of both like in the powder form and capsules and as well as tablets. Okay. Here the three regions like North America, US, Canada and Mexico, there is a demand. In case of the European countries like Germany, France, UK, Spain, Italy, Russia. Then Asia Pacific, that is including India, China, Japan, Australia and New Zealand, South Korea and other Asian Pacific countries. And mainly if you see that key market players are like Unilever, the Procter Gamble Company, Patanjali, Ayurvedic Limited, Kairali Ayurvedic Group and Imami Limited and Himalaya Drug Company Limited, Dabur and so forth. So my suggestion is I feel under your leadership actually inviting these industrial persons from either Jendu and Himalaya, Dabur and Vaidyanath, Patanjali. If we'll have the pre-business meet with these people and targeting for expansion of this area under the cultivation of Ashwagandha, so that it will give confidence levels to the Ashwagandha farmers. So that is what I wanted. Okay. Thank you. Thank you, the organizers, for giving this opportunity. Actually, this is the unexpected one. Just after coming, just in the afternoon. So director sir told to me like an interaction with related to this Ashwagandha. Thank you.
Thank you, madam. Thank you. I think the journey is just started. As you said, the interaction with industry will be happening everywhere. Our institute industry meet is every 6 months. One meeting has to be invariably we have to conduct it in ICAR Institute. That is the mandate given to ITMU unit of institutes, Institute Technology. So we will, I mean, he has a lot of connections already. There are some, I mean, like what you said, like big companies, Jendu, this Patanjali may not come because they have already technology. But there are many other small scale industries are there. They are looking towards us. So those ones we can call and we can have interactions and we can develop some best material to them and we can source their material and then we can start doing some of the formulations and all. And regarding castor, we are very clear. We are very clear about that. Only one thing we are working. So that will also we will take.
I think small scale like self-help groups, small scale industries also will target so that can be also. It has to be reached to the basic level.
Yeah.
That is.
Yeah. You said well said. So
it will reach to the common. So if you know the importance and its benefits, so everyone, so that uses, automatically the demand will increase.
Yeah, that's what we want to do, madam, in commercial agriculture. First, creating a demand is an important thing. So once create market, that's what market-driven research, that we want to create the demand. So then only the area will increase, then integration will happen, all those things were there. So we just started because now it is only 8 months old new institute. So in the old, it is like a new wine in old bottles. Because why they kept in an old bottle? Because already we have a lot of expertise in case of biochemistry, organic chemistry and others. So we are doing for one crop of Solanaceae tobacco. Now chili, turmeric, ashwagandha and castor we are taking up. With all people help, I think we will go ahead in to meet the mission and vision of this institute. Okay. Thank you, madam. Thank you. I thank you. I thank Dr. R.K. Mathurji coming all the way from Hyderabad to participate in this conference, and he has given a very good, because we were talking, I mean, off the dais and many times going here and there, and it says also that you unko bulao, and whatever you are thinking that you make it clear and make him proceeding banake, ask him to send. That same thing we did with the turmeric and chili also. Now ashwagandha, of course, DMAP are not doing much, I can say confidently. They are because they have many other crops like medicinal and aromatic. Manish Das also we discussed very well. So with castor we are clear now. At least with this 1 year time, I have a clear plans what we have to do for each crop. So maybe we may not do much things, only each crop we may do 1 or 2 things, which will definitely create impact coming another 3-4 years. Yeah, timelines mein saath hi kar rahe sir. I think within 3-4 years we want to bring some impact in 4 crops. Of course, we don't want to give up our major crop tobacco. Focus will be there in there, around 60 to 70%. Another 25% only we do these crops. So with this hope and vision, I think I'm closing this panel discussion. And then thank you for all. Thank you, Madam, VC Madam, for joining today and also joining in a panel discussion. Thank you, Manivelu, as a rapporteur and also very learned expert in ashwagandha. That's what I said. We have good expertise in each crop, except to castor, of course. But maybe if you can help somebody, you can send. Yeah, of course, Hyderabad is not very far, so we can definitely do wonders. Okay, thank you all. So we have last program. I think now you can answer.
Yes, sir. On behalf of all, I sincerely thank Chairman, Co-Chairman, Panelist and Rapporteur for successful conduct of panel discussion on ashwagandha and castor. Thank you for your thought-provoking and valuable suggestions, Madam and Sirs. We'll definitely follow. Sir, let us break for 10 minutes and after that valedictory program will start, sir. Thank you. Chair and Rayas, I request Dr. R.K. Mathur sir, and I request Dr. Shyamraj Naik sir, Associate Dean, Agricultural College, Rajahmundry, to please come and occupy the seat on the dais. I request Dr. Persis Madam from Adikavi Nanna University to please chair. Madam, please come. And I request Secretary, ISTS, Dr. L.K. Prasad sir, to please come and occupy the chair on the dais. And I request Treasurer Dr. H. Ravishankar sir to please come and occupy the chair on the dais. I request the scientists to give floral welcome to the dignitaries. Thank you, sir. Please have your seats. We have been listening to the eminent speakers deliberating in the different areas since these 3 days of international conference. And we all embark on a journey of insightful dialogues, thoughtful, provoking perspectives, and infinite learning experience in these 3 days of international conference. Without wasting much time, let us go to the award ceremony. I request Treasurer Ravishankar sir of Indian Society of Tobacco Science to conduct award ceremony.
Respected dignitaries on the dais and of the dais. So in these 3 days, we are organizing nearly 25 to 30 lectures. The experts from different parts of the stations, or different stations. And I think that all are enjoyed the lectures. And we also organized the poster presentations as well as the lightning talks in 5 themes. And for each theme, we have one Best Poster Award as well as one Best Oral Award. And in Theme 1 and Theme 2 and Theme 3, so the number of posters are nearly 50 for each theme. So there are 2 poster awards are given for each theme, that is Theme 1 and Theme 2 and Theme 3. So in Theme 1, that is the genetics and genomic strategies For enhancing commercial value, the best poster award goes to M. Mahadeva Swami and C. Chandrasekhar Rao. Impact of climate change on FCV tobacco production. Okay. No.
Instead of Mahadev Swami sir, someone please come and. Is there? Okay. I request the dignitaries to please.
So the next one is L.K. Prasad et al. That is Leaf Chemical Quality Index. Dr. L.K. Prasad. So the next award, Samuel Naik, a parametric and non-parametric approach for tobacco yield productivity. innovation in active tobacco. The production, quality, prevention, supply demand.
Now I request Organizing Secretary of Indian Society of Tobacco Science, Dr. L.K. Prasad sir, to give his remarks.
Good evening all. Respected Directors TRI, Director Institute of Oilseed Research, and Associate Dean Rajahmundry Agricultural College, Persis Madam, and my Treasurer H. Ravi Shankar. So, there are no remarks during this 3 days journey, but I would like to just go through our proceedings. So, the inaugural session, chief guest was Dr. S.K. Singh, and the whole inauguration was with Vice Chancellors of Adhika V. Nanna University and Vice Chancellor, Vice-R Horticulture University, and directors from ICAR, Dr. R. Dinesh, G. Krishna Kumar from Vice President ITC, and Director Atari, Dr. Sheikh N. Meera, and then CEOs from ITC, GPI, and then AOL, and general managers from different companies, and then delegates of all attended, and it was a very successful inaugural session. And then we have release of publications of different corners of different sections. So we had and then followed by the theme 1 in session 1, chaired by Dr. S.K. Singh, co-chaired by the Vice Chancellor, Adhika V. Nanna University, Professor K. Pradmaraj Garu, and then followed by the NABARD ex-chairman, and then G. Krishna Kumar Garu for the plenary lectures, and then followed by the session 1 on theme 1 of the conference, Genetics and Genomic Strategies, chaired by the T. Janaki Raman, and then lead lectures, experts, eminent people, Dr. P. Anand Kumar, Dr. R. Dinesh, and Dr. Madhavi Reddy, of different crop experts, and then in their own expertise they gave their lead lectures, and then followed by the lightning oral talks for 10 minutes, and then followed by a panel discussion on invigorating Indian tobacco as a global giant, problems and prospects, chaired by Ashwant Kumar, Chairman Tobacco Board, and it was a very good discussion and outcomes from the panelers and members, and followed by then we had a poster session for the theme 1. Coming to the day 1, we have theme 2, new vistas in crop management for resilient commercial agriculture, and theme 3, new perspectives in post-harvest technology and value addition, hall 2. So this here also we have a chairman for the plenary lectures, and Botula Srinivas Brahmanand, project director water technology, and then AOL Asia Regional Agronomy Director Silverio Leandro, and P.V. Prasad, Director Sustainable Intensification Innovation Lab, Kansas State University, USA. So, and it was a very fruitful panel plenary lectures on different trends in crop management, sustainable agriculture, and AOI approach and possible impacts on tobacco supply chain. Coming to the session 2 of new vistas in crop management, chaired by P.V. Varaprasad, Director SSA Lab KS USA, and then Silverio Leandro. Lead lectures were given by the online Michael J. Stout, Professor Department Head, Entomology Department, LSU, and Professor Dr. P. Srinivasa Brahmanand, Project Director Water Technology and Sustainable Water Management, and Dr. J. Krishna Prasad Ji, exploiting curcuma species for ensuring quality. Followed by, we have a online from Dr. Manoranjan Mohanty, Advisor, Scientist, Chief Office of Principal Scientific Advisor of the Government of India and towards sustainable agriculture and carbon sequestration. And then Dr. Gaur by nematodes and reliable, convenient bioindicators. And in this new vistas in second session, we have oral talks from different people having different specializations from nematology, agronomy, and soil science. And we had a panel discussion on turmeric and chilies, chaired by Dr. R. Dinesh, Director ICR IASR, and Dr. T.K. Behra, Director ICR in Institute of Vegetable Research, Varanasi, and followed by our poster session of Theme 3 and Team 2 and Theme 3. In session 3, new perspectives in post-harvest technology. In a concurrent session, we have chaired by Dr. T.K. Behra and then Director R. Dinesh of ICR-ICSR in Institute of Spices Research. There are the eminent experts of Dr. E.V. Prakash Rao, former head CSR, Central Institute of Medicinal and Aromatic Plants, and Dr. C.H.V. Satyanarayana Garu, Professor and Head Food Process Engineering, and Professor Bhim Pratap Singh and Dr. T. Srija on different various aspects of medicinal aromatic crops, future processing technologies, post-harvest interventions, and variety licensing and facilitating business. So we had a discussion and then followed by online Director ICR National Research Center for Grapes, Dr. Kaushik Banerjee on the mass spectrometry-based authentication and safety evaluation of agro products, and followed by Dr. I. Srinivas on farm machinery and power, appropriate mechanization, value addition options for tobacco. And then we had a successful lightning oral tracks from 7 people from online, from Ghana, Dr. Stella, and then Rohan Sarkar, Sadvaita, Adrita Dam, and B. Jagan Mohan Reddy, and Dr. K.V. Satyanarayana, different from different institutions and of different specializations. Then we had a panel discussion on turmeric and chili, chaired by Dr. Dinesh and Dr. T.K. Behra. So, and then we had a very fruitful panel discussions and then outcomes from that particular interactions and discussions. Then we come to final day of day 3, where the theme 4 and theme 5 were planned and scheduled on next generation technologies for information dissemination, and you have innovative market interventions for commercial agriculture, where this was chaired by the Sheshmadhavji and then Dr. Neeraja Prabhakar, Vice Chancellor, Sri Konda Lakshman, Telangana Horticulture University, and we have a lead lecture from Dr. Anil Rai online on Assistant Director General ICT, and then Dr. Neeraja Prabhakar on the new perspective in chili turmeric cultivation for sustainable farming. So, and then the next generation technologies for information dissemination and digital agriculture, followed with the lead lectures chaired by the Neeraja Prabhakar and co-chaired by Professor V. Persis Ekineyu. So the lead lectures were P. Venkata Suresh, Director School of Computer and Informatics, Information Sciences, Indira Gandhi National Open University, followed by the Murali Krishna, Professor NFTM, Exploration Nanotechnology and Agroecosystems. And then we have oral lightning talks by the H. Ravishankar and P. Prashanti, GPL Limited, and M. Rajababu and Sridhar Reddy. So this is the third days, and we have a very fruitful panel discussion on Ashwagandha, caste and mechanization, chaired by Dr. R.K. Mathur and then M. Sheshmadhav Garu. So in innovative market intervention session 5, we have lead lectures by Dr. Raghunath Reddy, Dr. Raka Saxena, and Senthil Ramadas and Srimati Nitasha Dagar on necessity of ISO standards, Senthil Ramadas and evaluation of agriculture markets, and Dr. Raka Saxena from market intelligence, and Raghunath Reddy on market intelligence and value chain for commercial farming. These are the 5 themes, especially all spread over 3 days and excellently done, scheduled by all the lead lectures given by the eminent people. So we I congratulate all the people and delegates who had a very good interaction and then gaining of information, knowledge, and all the topics across the different themes. So I thank you all for the attending in this international conference. I thank all the people who are actively participated. So thank you once again. I gave the mic to my followers. Thank you.
Thank you, sir. Now I request Treasurer ISTS to give his remarks.
Respected dignitaries on the dais and off the dais, and good evening to one and all. So these 3 days conference, which is comprised of lead lectures and lightning talks and panel discussions, plenary lectures and posters and oral presentations, and followed by the cultural program. So you can see this is a combination of orals as well as posters. So N components. So we have the N components in this conference. And when we initiated this conference by calling the experts, and we never expected this much response. Why? Because nearly 30 to 35 experts are said as, at the first instant, they are ready to give or deliver the lecture, either online or offline. And second one is, the experts from the different institutes, not only in India, and they are participated online, and they share their knowledge. And I think these 3 days celebrations, 3 days deliberations will definitely improve our knowledge. And if we organize this conference successfully means, so there is a meticulous planning behind this. So he is none other than our director, Dr. M. Seshmadhav. So because he always says one word that is called switch to gear. Okay, switch to gear means if you have less time and if you have to do more work, then directly go to the switch gear 5, not gear 1 and 2. It will not solve our problem. So in every meeting he says that word, switch to gear. So in last, 1 month or 2 months, so all our staff members worked like a T20 match. Okay, everyone participated and everyone did excellent work. So that is the result of today's evening. So how the conference was conducted successfully. So thank you, sir. So thank you very much for giving this opportunity as a treasurer and organizing this function. Thank you. Thank you one and all.
Thank you, sir. Now I request Dr. Persis Madam from Adikavi Nanna University to give her valuable remarks.
I'll take less than a minute. A big congratulations to Dr. Seshmadhav Garu and his team, the whole team of CTRI, renamed as NIRCA, for conceiving this, conceptualizing and concluding this event in such a great manner. Shall we all join our hands for a big round of applause to Seshmadhav Garu. Thank you. We organize many programs in the same premises, but at most we can bring 2 or 3 scientists for an event. But since 3 days I have been participating in the events, it has been a feast both to the eyes and the ears to see and listen to such eminent scientists who have come here from Pan India. So really it's a great opportunity for Adikavi Nanna University, and in this context I should really acknowledge and appreciate our Vice Chancellor Professor K. Padmaraj Garu, who has come forward with a big heart, welcomed CTRI to have this kind of grand event here. Hopefully this collaboration, this initiative helps us to move forward in a positive way with respect to exchange of ideas, knowledge sharing and collaborative research projects. Thank you for giving me this opportunity.
Thank you, madam. Now I request Dr. Shamraj Naik sir, Associate Dean from Agricultural College, Rajahmundry, to give his remarks.
Good evening to one and all, respected dignitaries and dais, our young and energetic and dynamic director Seshmadhav ji Garu and Mathur ji Garu and my friend L.K. Prasad and Madam Persia Madam, and off the dais on this one. This is Dr. Chavan Shamraj Naik, Associate Dean, Agriculture College, Rajahmundry. I am very happy to be here on this auspicious occasion. Could not attend the last 3 days because of the hectic schedule, but I regularly send my students 3 days event, and also I sent my professors also. They conveyed the message. This international conference is conducting the very excellent manner. In this contest, I congratulate all the CTRA staff, especially man behind this one, the Dr. Sheshu Madhav Garu. So it is very wonderful in conducting an international conference in Rajahmundry. It is not a small task, it is a big task. Bringing this scientist national level, international level, and gathering here, making their own platform, it's a very big task, but that was done by very easy manner. Just now Ravi Shankar sir told that we just played the match just like T20 match, very hectic, but even though you could succeed very much, so I am very much happy to be here, all these things. So anyhow, I got the opportunity to attend at least a valedictory function. And also we are not separate, the Agriculture College Rajahmundry and CTRA is not separated. We are together always. Why? Because whenever we conduct the functions in our college, always CTRA director will come and bless the students. He was one of the permanent guests for us. So he always given the many motivational speeches to the students, and they are very much inspiring. So very thankful to in that contest Sheshu Madhav ji garu. And also now the college has been constructed means only because of the CTRA lands. The CTRA himself, they provide the lands, and then only that college has been constructed. And Agriculture College Mahanandis have been there in 14 years. We have been there in the rented buildings. Last 1 year, May 10th, 2010, it has been inaugurated, and we have shifted from the Icftca College campus to the Icftca College campus to the July 1st. Now it is running the Agriculture College in its own building. Whenever you get the opportunity, please do visit. This all happened because of the cooperation, extending cooperation from the CTRI. I always very much thankful to the CTRI and ICAR, to those who are provided the lands. And also I congratulate all the winners of the paper winners of this contest and international conference, and also to others. And one of my students also got the prizes. I felt very happy. And regularly our students are conveying messages. They have very good lectures have been delivered here. They have learned a lot out of this conference. Definitely not only student community and also to the farming community. Definitely this conference will be useful to them. With this one, and again the new chapter will be opened for the CTRA in the Rajahmundry. So very happy. Once again I congratulate to CTRA team, especially the Sheshu Madhav ji garu. Thank you very much for giving the opportunity. Thank you very much.
Thank you, sir. Now I request Dr. R.K. Mathur, sir, to give his valuable remarks.
आप सभी को नमस्कार, कॉन्ग्रेचुलेसन्स, अ बिग कॉन्ग्रेचुलेसन्स। ज़्यादा बोलेंगे तो नाराज़ हो जाएंगे, क्योंकि 4-5 दिन से आप लोग बहुत बिजी रहे होंगे, और जब प्रोग्राम एंड होता है तो सबसे ज़्यादा खुशी होती है। जैसे स्कूल की छुट्टी होती थी ना, उस समय जो खुशी होती है वही हाल अभी यहाँ का होगा। आई नो इट्स नॉट ईजी टास्क, इंटरनेशनल कॉन्फ्रेंस फॉर पास्ट 13th onwards it is going on. Definitely all staff would have been very busy, all it is teamwork. Congratulations Madhav Garu and team CTRA for all you have done. I think hospitality also should have been wonderful, and participation of students, definitely it is very encouraging. And what a recommendation conference, definitely that will have a lot of say in R&D activities of this institute. At the same time, they will be helping policy makers in taking proper decision for implementations. So once again, congratulations and thank you very much for inviting me to this event. Thank you. Jai Hind.
Thank you, sir, for your valuable words. Now, as a token of respect, I request President ISTS to give to do felicitation ceremony. First, I request to Shamraj Naik Sir, Associate Dean Agricultural College, Rajahmundry. I request President ISTS to felicitate Sir. Now I request President, the man behind all this, Indian Society of Tobacco Science International Conference, to give his valuable remarks.
Thank you. Good evening, friends. We come to the last leg of this international conference. Yeah, I don't talk much, but I want to talk one or two important things. When we decided to hold this meeting in August 20 this year, that time we were discussing why we should have an international conference. Because the institute is going to change from one crop to four more crops, together 5 crops with the commercial agriculture as a banner. Then if we can conduct this international conference, we can connect all the people of the different crops like castor, chili, turmeric, ashwagandha. And we would like to tell boldly to all the ICR fraternity and non-ICAR fraternity that we have shifted, we have diversified to 5 crops. But again, I can say that our focus will be on tobacco, major focus, and little focus on other 4 crops, definitely with the commercial agriculture banner. So that time I had only one scientist, great scientist with me, and he was with me all the time, and he told me he's other than Dr. Chandrasekhar Rao, CCS Rao, we used to call lovely, I mean, with great love. And then we discussed, we thoroughly discussed. Many times whatever he says, he may not, he won't accept. Many times whatever he says, I won't accept. But we come to the point after 2 days that we should have tobacco and commercial agriculture for preparing for future farming. How should be the future farming should be there in coming days. Then we read about agriculture 2.0, 3.0, agriculture 4.0, what are the components in for that. And we discussed a lot for 2-3 days. There were nobody except Dr. Chandrasekhar Rao. Then we got a very confidence that yes, we can do, because many of the, we also saw many conferences, where any conferences happened on this. Then there are some components like climate change were addressed, some of them decarbonation were addressed, but not all the issues. Not all the issues of commercial agriculture were not addressed in any conference in India. Then we thought, okay, we will have an international conference on tobacco and commercial agriculture for future farming. So that was the genesis for this international conference. It is happened in August, before my birthday, and then I've been to Nam, and then and after that the second person who are always, 2 persons were always with me is Dr. Ravi Shankar and Dr. L.K. Prasad. This trio was there from the beginning for this conference from the August. There were other people, but I just want to say that genesis happened like that. Then we kept a small brochure and we decided themes with the help of all the heads of the divisions like Dr. Sarla, Dr. Kasturi Krishna, Dr. L.K. Prasad. I think that time Rajshekhar did not join, I feel. August, did you join? Yeah. So Rajshekhar also was there. And then we discussed and we kept all the 5 themes, which all know. They covered all the aspects. And in this, during past 3 days, 57 lectures were there. I just counted now. There were 57 talks. And there were 5 poster sessions, and importantly, 3 panel discussions. Very elaborate discussions on tobacco, chili, turmeric, ashwagandha, and castor. Definitely we have a very good plans. My colleagues now got a good plan for what we need to do for coming 4 years or 5 years. We will make a proceedings, we will make a small action plan on this, then based on that we will continue to work on that. So after this journey started, that we thought we will do casually in our institute and all, then again we thought, okay, we have another program actually. On 13th December we completed, that was a Platinum Jubilee celebration, which is invariably we have to do in our institute, because it's a Platinum Jubilee, we cannot go outside. Then we did that. So then people said that we have to do 2 different times. Then I said, no, we should go together, so that because CTRI, 6 registrations spread across the India, people have to come, and our NRPT centers are also there from different locations, they have to come again. So 2 times calling is not good. So we thought of doing only 1 time. So that was the genesis, and that started, and we completed Platinum Jubilee very happily on 13th, and then conference completed now. So for that, the venue was deciding, then there was a lot of things we decided, but with the help of Dr. Persis Madam, with help of Ravi Shankar, we thought, why can't we do at Nana University? Then we came, I don't know, VC Garu, Dr. Padmaraju Garu, I really don't know. I came and I talked maybe 1 time and 2 times maybe. First time only he said okay, but after that he said, after 2 times I think he readily agreed. and with his great help, with his generosity, with his academic instinct, today we could complete successfully for a 3 days conference very nicely in this campus, madam. A lovely campus. We should give all big hand for this. Dr. Padmaraju sir is not there. I thought he will be here, but he's gone Vijayawada. I came to know that. But definitely I will personally meet him tomorrow or after tomorrow. With his help, with his generosity, we could come here. Although we had many points in mind that it is very far, how we need to manage and all those things. But excellent campus, and your staff were excellent, and all the 5 people, Passis Madam, Ramaneshwari, Jagan Mohan Reddy, and Principal Sir, and other person, I forgot his name, all the 5. Jagan was there even for a whole night. Of course, he is my good friend. Before coming here also, I know him. He was there even right up to night, 12 o'clock also, the previous day of this conference. So all they helped, and I really indebted to you, and our collaboration with Nana University with this conference will strengthen further, not only projects, not only student exchange, technology development and technology validation, and creating impact in Godavari districts. I promise that we will definitely create impact, at least in 1 or 2 aspects. So that is a commitment. That is the commitment I took now, and then we will definitely create an impact for you. And also, I am there in some committees wherever I am there, I definitely help the Nana University to go to the greater heights. So that is the thing. After that, I mean, there were several, as my organizing secretary said, there were several. We almost invited 7 institute directors, like Dr. Mathur, Director IOR, Director IASR, Director Indian Institute of Vegetable Research, Director Atari, and there were 3 VCs. Nana University VC, of course, host, and we called YSR Horticulture University, and Telangana State Horticulture University. There were 3 VCs. So really, it is, I mean, I was having a little bit doubt, but as Ravi Shankar says, I always put from gear 1 to gear 5, because I don't want to waste much balls. I am really a T20 player. I love the cricket. Many of my colleagues knows that. So because when asking run rate is more, then we need not to waste balls. So we need to go to the very faster speed. So that's what we did, and we could succeed. So in that many committees we made, all the committees chairmen, members, my scientists, colleagues, technical officers, technicians, students, and my own students really worked hard and made this, scientists which came from all the way from my regional centers also helped a lot and made this event very successful. In that I want to say thanks to all the people, and some of the scientists, may God, sometimes maybe in these 3 days when program was going this side, that side, I may be cursed, maybe I showed my wrong face. Don't mind. When Taj Mahal is created, you all know, maybe thousands of people, hands are broken. So in this process, this will happen. So because I feel it is really proud for the CTRA to come out of the campus and doing, I think it is the first time. What Dr. Rao Garu? Yeah, Hyderabad you could do. Yeah, that time I was there. Yeah, but that was again Agriculture University. So, but this is a traditional university where we don't have much connections, but could do very nicely. And for that, our organizing secretary is very cool and very calm. Even you say 100 things also, he won't to say anything. Such a cool person. Yeah, such a cool person, Dr. L.K. Prasad. Similarly, treasurer also. Whatever I say, even if at night 12 o'clock also I used to text, he said, yes sir, we will do. So that is the, support I got, especially from ISTS. And I want to thank 2 important people here, apart from VC, that is my friend Shamraj Nayak, Associate Dean of College of Agriculture, Rajamundry, and he could not come, but he has sent all the student delegates in a big number, for the 3 days, and he spared, even he sent his colleagues, and they came, and students participated on a hackathon and got prizes also, of course. But your help really commendable, Dr. And we will continue to collaborate each other in a process of this thing. And then one more friend, I think you all know him. Just he came for 3 days. He came on 12th night. 13th he was here, 14th he was here, and 14th night he left. Who is my friend? He is a Dr. Professor J. Suresh. Suman Kalyani, he worked in a publication committee. He almost reached all the presses, Hindu, Indian Express, Deccan Chronicle, and especially now, tomorrow or day after tomorrow, there will be a 30 minutes program in Doordarshan on Platinum Jubilee as well as for this conference. So he could galvanize many press people, and he brought very good coverage. Coverage yesterday I sent to DG sir and as well as DDG. DDG first time he shown the thumb icon. I felt it very happy. So because DDG is my boss, I am the first student of him. He never shows happiness on the face. But he will tell anything goes wrong, he immediately tells. So that is he is like that. So, but when he said thumb signal, I really felt, I felt very happy. So that is the thing. And there are many people, if I take somebody's name, we may say that you just said, but if you feel or not feel, for this conference, Mr. Lakshman and Mr. Kumar, really their help was commendable. And commendable, he is all the way, he sat 3 days here, I saw him, he was doing all the corrections, making this thing. Similarly, Lakshman took care of all the guests very nicely. And of course, without help of sponsors, the great sponsorship from ITC, they are valued partners. They continue to be valued partners in our tobacco journey, even in a NIRCA journey. And with ITC and Polishetty, Shamsundarji, GPI, AOL, VST, they came. We asked, we did not, ask much. We only showed one video of curtain raiser at Gunturu, and they came. That is they feel that the Tobacco Institute or us, we also feel without their support, we have not done any program so far. And the support, Mr. Reddy, BSR Reddy is here, Dr. Reddy is here. I hope he will convey this message to the Krishna Prasad ji and also Ram Prasad. We will continue because I think we also made MOU, historic MOU with the 4 projects of around 1.3 crores. And with that also we will have a commitment of research to deliver some products together, so which we will definitely do. So I also want to thank the people involved in the Platinum Jubilee. Maybe I'm taking a little more time, sir, pardon me, because it's a big event. The Platinum Jubilee coordinator, Dr. Anuradha Garu, she all the way came from Kandukuru, stayed for almost a week now. And before that also she was coordinating from online, and with her help we could do. And second, but really she became sick with this work, Dr. Kasturi Krishna, publications, wonderful publications, madam. And ADG was telling all the publications you should bring, especially Diane's and Coffee Table book has come very nicely. I was telling that this book has to be kept in this way. So we changed around 5 times, but one person, Mr. Elias, he was very, one person, Mr. Elias, he never shown any time any disappointment on his face. Whenever I said, what you are doing very wrong, even then he changed. Many times I said, no, as Elias, aisa nahi karna hai, again he changed. Many times, 4 or 5 times format we changed, and with his help we could do the publications very nicely. And also with help of Dr. Sarla madam, in charge for the invitation, many people, almost we galvanized 1,000 to 1,200 farmers, 600 to 700 farmers, altogether 1,000 to 1,200 people. Our previous director, Dr. TGK Murthy, and retired scientists like C.V. Narasimha Rao and others have witnessed that function very grandly. I'm really happy with that function. There were some small things that happened, that's okay. We will improvise, and when we come to the next time, maybe we will do much better. And last but not least, there are two people I want to mention, that is Mr. Verma and Mr. Sandeep. They are almost like right and left hand for me. I mean, yeah. So they not only doing the work of year as a research scholars, but they are doing work for even my personal work. Because yesterday I was sitting here, my son was traveling from Kottayam to here, and there was some hiccups in doing digital transactions and all. And I'm doing from this podium, but I could not do. Then I said to them, they are doing. This is only example. I mean, they are doing a lot. So I must thank you. Thanks for their help. And and also I feel they will be continually, they will be working some more time with me. And of course, all my staff, personal staff like KTR and administrative staff and finance, everybody helped. And we could successfully complete it. And the thing is that maybe we will take a break for another 1 or 2 days, but action plan on all 4 crops that will be that work is still pending. I think that we will complete maybe in Monday or Tuesday with help of Kasturi and Dr. CCS Rao, Chandrasekhar Rao, and we will take a maybe break for the Christmas. So with this all thing, I thank you all. Maybe I forgot 1 or 2 names, but it is definitely Parmesh is there, Anandita is there, and then our Hema is there. Who is that? I forget, entomologist. What is her name? Shailaja is there, and many others, of course. Many others worked. All, as the Treasurer said, all the CTRA, NIRCA family, as a team we worked. This team spirit should continue even in the research, even in the development of products, even in creating an impact. I am calling an impact because unless we create an impact in tobacco or turmeric chili, we will be nowhere. The days are gone, the glorious days of 75 years of CTRA has completed, but to become a glorious for another 25 years of 100 years when we are going to become Amrutakal, we have to work maybe 4 folds. I request and I appeal my technical officers who are in a large number in CTRA, NIRCA, they should change their gear. Maybe like me, they should put gear 1 to gear 5. Let us work together. You all are there in a great number. You should come and you should take responsibility and work more. Some people are coming and some people are still in a waggering this side, that side. Don't see anything. If you want to hit 6, you can hit 6, or maybe you will get out. Maybe first time you will get out, maybe second time you will get a 6. Okay? So that is the fashion you should work. So I request and my strong appeal to all technical officers. So with this note, I thank all the delegates who came from the far places, and whenever we called, even we could pull the people from Thailand, we could pull the people from Louisiana, Kansas State University, all those things I don't want to talk. But anyway, coverage of the press also good. I thank the press committee, Madam Suman Kalyani. Of course, Suresh was there, but she's behind the screen. And thanks to your help in cultural. Supta Prasad ji, what is his name? Prasad. Prasad ji has come with wonderful kids, sir. I think that was really memorable. Suman Kalyani has coordinated that. Small kids of 5 years to maybe 12, 13 years, they did a wonderful cultural event we had. And I forgot one thing, the food was good. Of course, they did a lot of, there were some small hiccups. Definitely we will improve this thing for any lapses. Any event will not complete without lapses. We cannot be 100% correct. So there will be some lapses, those we will be correcting, and we will, when we conduct a next event, I think we will do much better than this. With this hope, I am closing my talk. Thank you all. Thank you NIRCA family. Thank you CTRA family. Thank you.
Thank you, sir. As we inch towards the closing of this illuminating conference, I request Secretary ISTS to propose formal vote of thanks.
Okay, sir. Please allow me a formal vote of thanks, sir. At the very outset, on behalf of Director CTRA and President ISTS, I would like to thank our chief guest, guest of honors, lead speakers, and then panel chairmen, plenary lecture speakers of the different sessions, and then eminent speakers from different institutions, and directors of the ICAR institutes, and then vice chancellors who gave acted as a chairmen and co-chairmen and gave their remarks and then discussions. I thank very much for that, and I would like to thank and then the panel discussion members of chili, turmeric, ashwagandha, and then mechanizations. So I would like to thank them. I would like to thank all the nodal officers deputed from Adikavi Nannaya University for the conference, for their tremendous support during the conference. And I would like to thank profusely the delegates from different corners of the country who actively participated and give their oral lectures and poster presentations. And I would like to thank all the different committee members also. And I would like to thank our sponsors, ITC, GPI, PSS and VST. And then I would like to thank the companies who showcased their products in stalls during their conference. And last but not the least, I would like to thank all the people who are directly or indirectly supported and helped for the grand success of the conference. Thank you.
I request all to stand for national anthem.
Yes, sir. Just to say.
Sir, आइए.
Please, please. Please, sir.
मैं आइए सर, आप अपने हाथ लगाइए. ये सब GPA कंपनी का है सर. Water Philips India. They work very hard. Puneet and his Oma and Thank you. Thank you. Thanks a lot, sir. Thank you. Thank you. Madam. Thank you, madam.
I should not tell, no?